This conference will now be recorded.
Okay, right. So, what is a Docker? Why should we go for the Docker? Now, where the Docker is like in our current process, the automation of your continuous integration, continuous deployment process, where the Docker is going to play a role. Okay, we'll see. Then we'll start using the Docker. Right. So now, usually the Docker came into the market for a solution, like for a like we are facing some kind of problems. To resolve the problem, the Docker came into the picture. So nothing but I need a server. The problem is nothing but I need a server on fly, right? So now if I want to have a server, suppose there was no cloud, if there was no cloud, so by that time only the process is virtualization, VMs, virtual machines. So when a person like a testing team or some XYZ person looking for a mission, then they have to raise a ticket to the operations team, and they are going to allocate a mission to that person. So this is a process. This process will take 1 to 2 days of the time to allocate a server to the person. They have to give a clear explanation why he's looking for a mission. Right. So now here the thing is, right. So now when I need a mission, I am going to send a request to the people, operation team. They will respond. They will raise a queries. Once the queries are resolved, then they are going to allocate the mission, and with the restrictions again on the mission, and there will be some restrictions they are going to put so that you are not going to touch other part of the area of the servers or the software, whatever you are going to play. This process will take around 2 to 3 days for us. After that, again, we are going to start working on the mission. So my task is nothing but I want to do a kind of sanity testing, so something like that. So I want to confirm my application is running as expected. So just a basic flow I want to do. We are going to call it a happy path, something like that, a sanity testing, nothing but we are going to validate the application like the outside, so the complete flow is working or not. For that, so now the task is nothing but every sprint end, as an example telling you guys, every sprint end we are going to give a demo to the POs. So now before going for the demo, I want to have a server. On the server I want to uh, deploy this application, right? So then I want to test it so that I am going to confirm on any mission my application is working without any flaws or any issues. Then I will go and deploy into the UAT environment or somewhere, then I am going to give the demo. This is a kind of requirement for me, right? So now here it's a sprint level activity. Now the sprint level activity means every 15 days you are going to perform this activity. Once the activity is completed, again you are going to wait for next sprint, means next 15 days. So now here in the process, when I want a mission like 3 to 4 days prior, I need to raise a request to the operation team. They are going to allocate a mission to me. Then I'm going to start testing on that. If any issues on the server side, again I need to raise a request to the operation team. Then there is a chance of delay. Right. So because right, so there will be a n number of reasons the servers may not respond to what you are expecting. There are n number of reasons will be there. Right. If the problems are in our hand, we can resolve it. If the problems are not in our hand, then the respective expertise has to come into the picture, and they has to resolve it. Right. So like there are many things we are going to we are facing in the past actually. So now to overcome these things, the DevOps came to the picture. That is quite common. And this area, particularly this area, what I'm talking about, the testing of every sprint. So now here the process is a typical process. There are multiple teams are involving. Due to that, we are seeing the delays. And the end of the day, we are not delivering the demo to the viewers like these reasons. So now here the thing is the control has to given to the testing team, so that the control means the server creation. If I give a control to the testing team, so that when they want this, right? So now here 2 days prayer or 3 days prayer, that is in their hand, so that they can decide, okay, now I need a mission, means then they can go and take the mission. They don't need to raise a request to the operation team. So now because they know when the mission is required, right? So now here if we give the control to them, then this kind of delay can be avoided, right? Multiple teams, we can eliminate the one team, so that this is the guy who is going to create a mission. But we cannot allocate we cannot give a permission, something like that, the people they can create a mission on fly. It's a costly thing. When I go to virtualization means it's a costly thing. Unless many people testing team means there might be 10 people or 15 people. 15 people are trying to create a mission means that's it. At the end of the day, the budget will be gone. So right, so now here it's a simple example. Like not this is the reason not the Docker came in the picture. The Docker has some other reason. Just a kind of example I'm trying to give you guys. So then if I take something like that, so now here the something like that means if I give a server which is a lightweighted server, means we are not going to provide each and every component of the OS. Right, so means I'm not going to give the GUI because he wants to do some kind of testing. For the testing, he don't request the GUI. Just he is going to take a mission on the mission. Whatever the software needed, those will be installed. Then he is going to perform the testing, and at the end, he is going to see the results. Then finally, terminate the mission. Right. For that, I don't require to provide a GUI to them. Right, as an example. Right. So now the lightweight mission means whatever the components are required, those we are going to provide. The extra components are not required, like the GUI or some hard disk or something like that. Those we are going to remove it. Right. So now what will happen here? Usually, if in a process, if I want to create a mission, it will take minimum 10 to 15 minutes. Here, it will be like hardly less than 1 minute. Right. So now here the time is we are saying the time when creating a mission. Then the installations of the softwares. So the next part is once I got the server, then on the server I am going to install the softwares. So now here it is again one more challenge for the team, the testing team, because they don't know how to install the softwares. Because earlier the operation team is going to take care. So now here if I give a mission something like that, whatever the software they are looking for, if I give as a pack, I'm going to provide a mission so that they don't require to install the software. Right. So now here the thing is we are going to create a mission with them along with the mission, we are going to give the softwares also. Right. So simply now what they will do, they are going to test it. So there the Docker came into picture. Right. The Docker is not only going to give a mission to you, along with the mission, it is going to provide you the softwares also. Whatever you are looking for. That's why the Docker we are going to call as a container. Container means a pack thing, right? So it's going to carry the stuff, right? So means what the Docker is going to carry here, it is going to carry the server, along with the server, the software, the configurations, application code also. Your code also will be carried by your Docker. So means Docker is a package. The package is a combination of a server, softwares, configurations, applications. What are the application you want to. So now here I don't require any operation team now. I don't need to raise the tickets to them. Simply I can, when I need suppose I need a .NET mission, Visual Studio mission. Simply what I will do, I am going to tell my Docker I require a Visual Studio mission. It's going to give a mission to you with the Visual Studio. Suppose I require a Java mission, I'm going to tell the Docker to give a Java mission to me. It is going to give a mission to you along with the Java, like that. Right. So now here you are going to get the pack. Now on the pack, you can deploy your application, or along while getting the mission, you can deploy the application also. Means before launching the mission, you are going to tell the Docker like I needed a Java, I need a Tomcat, and I want to deploy this application. Then the Docker will create a mission along with all the stuff. So that's where the Docker become very, very popular. So that means anyone can handle the servers now. Earlier days, only the operation team is going to handle the servers. Now anyone, as a developer, as a tester, or a HR also can handle the servers like that. So like that, the Docker is become very, very popular. Means the complete configuration stuff is eliminated. Whatever you want to configure to create a mission, everything is eliminated. Simply just you need to pass the instructions. You need to run the commands. Like in our AWS, whatever the instances we are seeing now, the same thing will be the Docker. We can correlate with the AWS, right? So now here, when I need a mission in our AWS, simply we are going to tell the AWS like we will go to the EC2 service, then we are going to click go. That's it. Automatically, mission is going to launch. In the same fashion, our Docker also will be work as the same. Not only it is going to provide a mission, it is going to provide the software, and it is going to provide the application also, right? So now suppose let me go to our AWS once, and I will show you. Like we can exactly our AWS can be correlated with our Docker. So let me log out. Not only AWS, any cloud can be correlated with our Docker. If I go to the EC2 service, if I want to create a mission, usually we'll go to the EC2 service of our cloud, nothing but AWS. So now if I go to the EC2, from that EC2, we are going to click on launch instance when I want to have a mission. Right. So now here I am going to click on launch instance. Right. We are taking Amazon Linux 2, right? Usual for our practice. If you guys observe here, there is one more AMI, Amazon Linux AMI. It is a 2 AMI, it's a AMI. Here you can observe it is having a pack of Python, Ruby, Perl, and Java. And also these will be the default softwares we are going to get once you created a machine with this AMI. And also you are going to get the repositories like Docker, PHP, MySQL, PostgreSQL. You will be having the packages. Just you need to install if you require. Otherwise, you can leave it. But these guys will be the default you will be get. Right. So now here I am going to get the mission along with the softwares. Right. So now here when I want to have a Java, I don't require to go to this one. Simply I can take this AMI so that I will get the Java like that. When I want to have a MySQL database, right? Simply I will take the this AMI. Then I am going to install MySQL because already MySQL package is available. The repository is available. Right. As a pack, we are going to get this. The same in the Docker also. Now with the Docker, the advantage here is not only the software, you can have the application also. Whatever the application you are building up, that application also can be default, can be deployed as a default like this. That is one more. That is a extra advantage with the Docker. That can be handled with our AWS also. I will show you in our AWS class how to handle with the default application code also with the AWS. Okay, right. So now here, now when I compare with the virtual machines along with my Docker, the Docker is a lightweighted than the virtual machines or the physical servers, any server. Here, guys, you need to remember Docker is nothing but a server. It is also a mission, like how we are going to create a mission with the AWS instances. Likewise, our Docker is also a server, but it is a lightweighted means it is not going to have all the required softwares. Required means the softwares or the packages or the components are required for the OS. It is not going to have all the components. The mandatory one only it is going to have. The rest we need to install if they are required. Otherwise, go with the default stuff. I want to have, suppose I want to have a Java on the machine, right? So you can take a default server, default Docker container, then you can install the Java also later on, like how we are doing on the AWS instances. Right? We are taking this mission on the mission. When I want to set up a Tomcat, I'm installing the Java, then follow with the Tomcat. The same thing can be handled with the Docker also. Right? So now here, now when I compare with the virtualization, what VMs are the physical servers, usually the Docker is a lightweight server. So now where exactly this Docker is going to use, right? So now where exactly means, as an example, I have given the example like the testing team required mission. Usually the exact area of the Docker is microservice architecture, right? So now here, what is a microservice? Just I will give you an overview on the microservice. Right. If I take any application, right? So suppose this is my application which is deployed on the server. So now on the server, if I take the banking application, or Paytm, let me take the Paytm. Suppose this is my login module on the Paytm, and this is for the recharge, and this is the recharge module, and this is my what else is there, like shopping, and this is my banking. Right. So now these are the modules which I'm having my Paytm application. Right. So now here this application is running on a server. Suppose if I treat this as a server, that is fine. Right? People are trying to connect this server, and they are going to access the application. They are going to do what things? They are going to browse the respective means the modules. Suppose if I want to do the recharge, I will go to the recharge module. Means my request will go to the recharge module, and I will go back. Let's suppose if I want to do some kind of shopping, means the clothes or electronics, then I will go to the shopping module, money transactions, right? So now here there are the modules are there in the Paytm. Then we are going to go to the our request. Here means our request will go to the respective modules, and it will be get responded. So now here, suppose banking is down, means the application, in the application, this is the overall application, and the application, this banking module have some problem. So what will happen? Usually we are going to see the complete downtime of the application. Okay, right. So some in the application, one part is having some problem, is it is going to down the entire application. That's what the monolithic way of application deployments or monolithic applications we are going to call. So now here, if any area is impacted in the application, it is going to down the entire application. Or if my server, suppose this server is having some problem, if the server is down, obviously your application will be down, right? So now here, now the problem is, so if any problem with the server or any problem with the in the application in an area, like suppose if the banking is down, still like so it is having some problem with the banking, means people cannot transfer the money, but here I can do the shopping, I can recharge my mobiles, right? So rest of the models can be utilized, but here the problem is, if something is failed, entire application is going to go down in the monolithic way of applications, right? So now here in the current generation, means right, the technology is going rapidly, right? So now here, uh, now there is no dependency between my banking and my shopping, between my shopping and my recharge, between my recharge and my banking. So by that time, why should I need to create a dependency? If there is no dependency in the application, why should I have this kind of dependency? Let's eliminate the dependency, so that if something is failing, let's fail at that particular area only, not to the other areas. You should not touch the other areas. So there what the new concept came to picture is microservices. That means they are going to split into the parts. So it's not in a single server. Now it is going to deploy into multiple servers. So now here, this will be my login module, and this will be my recharge module, and this will be my shopping module, and this will be banking. Okay. So now here, if my banking is not working, right, so there is no dependency to the other modules, still they can utilize, still they can serve to the people, the customer, right? So now this is how we are going to handle with the help of microservices. Microservice is nothing but the entire application will be divided into pieces. Now each piece will be deployed to a separate server. So now it is become a server. Each piece will be running in a server, right? So now here, what is a server here, right? Yes, a server is nothing but it can be a physical machine, it can be a virtual machine, or it can be a cloud instance, or it can be a Docker container. So now the servers, like physical servers, virtual machines, cloud servers, are the Docker containers, right? So now here, now when I have multiple servers, which one I should take? I should take the physical servers, or I should take the virtual servers, or I should take the cloud servers, or the Docker containers. So now out of all the four, the Docker is the one which is the best for the microservice application management. Why means, if suppose if I take, apart from the Docker, if I take the physical servers, virtual servers, or the cloud server, if the server is down with any reason, to bring back the server, how much time it is going to take, right? So now here, only the two things we are going to, people means not from the customer side, from the business side, people will focus on the two things only. One is cost, second one is the time, right? Right, what is the amount I'm going to spend to have the high availability of the scalability of my application, how much time it is going to take for to recover the application. If something is failing, how much time we're going to take it. So these two things will be the key area for the application management, right? So now if I take 10 to 15 minutes to recover the application, then people will not agree. People means the business people, like the Flipkart e-commerce applications or the banking, they are not going to give the 10 minutes or 15 minutes time to recover the application. No way. You have to take it in a seconds, or hardly 1 minute or something like that, right? So there are application will be there with the different applications. When I'm going to talk about the sensitive applications, there we are going to when they are not going to allow this much of time to bring back the application. This must means some amount of time, right? So now here, when I'm going to compare all the 4 servers, right, every mission, every apart from the Docker, apart from the containers, everyone will take 5 to 10 minutes. Now for the Docker, hardly it will take seconds to bring up a new server, to bring back the server, or to bring a new mission. Anything. If you want to have server in the Docker, hardly it will take seconds. So that's where to manage the microservices, the containers are playing a vital role here when I compare with the other missions. Right. So now here, so now to the thing is, so the microservices are running on a servers. Now the servers are nothing but the Docker containers. Right. So that's what how we need to understand here. Right. So now here, if something is failed, so now here, what is the advantage here? Suppose my banking is failed here. So now what I am going to do here is, I am not going to check for the troubleshooting. Simply, I'm going to launch a new separate container with the proper code. That's it. So now here, I'm going to remove this one. I'm going to bring up a new mission. Hardly it will take for me to 15 to 30 seconds to bring a new mission, to bring up a new container here. Right. So now here, the core area of the Docker containers are nothing but to manage our microservice application. Right. So now here, not only for the microservice applications we are using, now we are using wherever a server is required, we are going to take a server, because as I said in our starting class, now the testing, now if I hand over the control to the team so that they can create a mission, they don't need to bother about me. They don't need to raise the tickets. Right. So now here, wherever the servers are required, now we are going to give a Docker containers to the people. Hardly to take seconds or minutes of the time to bring a new mission. Then you can utilize the mission. Then you can terminate the mission. If you want, again you can bring back. Bring back means you can create a new mission here. Sorry, not the bring back. Right, you can create a new mission here. Like everything can be done on fly. Right now here, now the generation is on fly. Everything should be done in on fly. You cannot wait for minutes also. Forget about the hours. We cannot wait for the minutes also. Right. So now here there we require on fly. On fly means, right, the solutions. In the solution part on the server side, Docker, the containers. Right. So like now here, not only for the microservice, we are using the containers when the people wants to have missions for the testing. That I will give one more example also, in our real time scenario. Right. So usually in our practice, in our CI/CD practice, continuous integration, content deployment practice, right? So usually the process will be, we know the process very well now. I think you get it. So the first one will be the code checkout. Code checkout. From that, it will go to the Jenkins. From the Jenkins, right? So next will be the unit testing. Then the next will be the code quality setup. Nothing but our Sona code. Correct. The next will be the artifact creations and storing the artifact into repository, then email. Right. So now here I record this stuff, this process only, means until this only. So now here we are going to scan the code, and we are going to get the report of the code quality, and this code quality will be published on the Sona. So now here we have placed a threshold value of 80% of the code coverage. So whatever the unit test cases they have created, on the unit test cases, the code coverage should be minimum 80%. If they're not maintaining the code coverage minimum 80%, we are going to fail the job. That's what the threshold value have placed in our process. So now here, when the people are checking the code, our CA job is going to trigger automatically, or continuous integration job. The process will go, and here it is going to check the code quality gate of 80%. It is failing. So now when the job is failed, what will happen here? It is going to send a email notification to the team. In the team, the managers will be there. Their lead and managers will be there. So now they will get the emails of nothing but this job is got failed. Why the job got failed means it is not meeting the gate. Right, so now the manager will raise a concern like why you guys are not making the code coverage. This is quite common. Right, so now here what they will do, they will start writing the unit test cases, the developer to increase the code coverage more than 80%. Then they are going to test it. So now this process is a continuous process, right? So now I suppose an example it is now 68%. Now they need 12% or more. So for that, how many test cases are required? What exactly the code I need to write so that I can get the 80%? It's a kind of guess only. So now they will start writing the code, unit test cases on the code, so that then they are going to test it. Then they will say 68 to 70%, now 71%, 71.5 like that. So now here this process will, right? So they're doing some, they're writing the test cases and triggering the job. Now the job is failing. It is sending email. So now here manager will wait for 2 to 3 minutes. After that, what he will think is these guys are not capable of writing the code, right? So now here what they will expect is, right, at least within 3 to 4 attempts they have to get the code coverage. Still he's struggling to get the code coverage. It's a negative impression to the manager. There is it's not like everyone is a genius here, right? So right, people, few people will be there like they can write the code like that only, like means within 1 or 2 attempts only they will get. Now people, some like other people, other area of the people will get 5 to 6 attempts or more than 6 attempts also. It's not like you cannot confirm like this guy is not fit for our project. There is some criteria will be there, right? So now here the thing is the manager will get the negative impression like this guy is not able to write the proper test cases. So now here our development team raise a concern like we don't want to trigger unnecessary the emails. This is our job. Your requirement is you need 80%. We are going to provide the 80%. Okay, but I don't want to push the code something like that. I don't want to face this kind of issues. So for that, what they ask us is we want to test it locally first. I want to test the code coverage locally. Now, if I get the code coverage of 80, then only I want to push the code into my GitHub. Then go for your process. Like I don't want to do some kind of testing something like this. I don't want to put my face in the public. Right. So then we require as a right, it is request to the DevOps only. Right. This kind of automations, everything should be managed by the DevOps only. So now here the request is for to us. The request came like they want to have a local setup, so that they are going to test it locally. Then they are going to push the code into the GitHub, our source code management, right? So now here the thing is I have like multiple, for a problem we are going to have multiple solutions, right? So now the problem is they want to test it locally. Then what we can do here is we can we can set up this complete code coverage, nothing but the SonarQube setup local limits on their laptops. We can install the SonarQube locally on the laptop, then you can ask them to go and do it. Here the problem is if some reason the SonarQube is not working, like I have it now in my project around 50 plus developers are there. Now if I install, go and install the SonarQube on all the 50 machines. Now the next immediate problem is someone will ping me on my mission SonarQube is not up and running. Then what I need to go and I need to check his laptop like why the SonarQube is not up and running. Now in the next 5 minutes I'm going to get one more request like my SonarQube is not giving the proper results. Right. So now here my job will become nothing but to not the DevOps. I am going to manage the SonarQube and the laptop. Then my job will become something like that. Right. So now here I don't want to go in such a fashion like go and do the maintenance of my 50 developers missions to manage the SonarQube. Right. So now I eliminated the process. So I don't want to go in such a fashion. So then what I did here is we have like solutions. So now here we have a Docker available, containers are available. So don't, why should I go for the installation of SonarQube and the missions instead of going on that way? I will set up a process. The process is nothing but on fly the Docker container will be created. Now on the Docker container, the SonarQube will be running as a default. As I said, you can get the packages also as a default. Now I am going to deploy, I am going to launch a Docker container with the SonarQube. Then simply what they will do, whatever the code they have written, they are going to send the code to my SonarQube. It is going to validate the code and is going to give the results on the on the mission on the Docker container. They will validate there. Then simply close the server. Server here in the sense Docker container. Stop it. Close it. That's again they want. Simply they are going to launch a new container. Right? Launching a new mission. Mission means a Docker container. Hardly it will take seconds. As I said, you don't need to spend 5 to 10 minutes of time to launch a new server. The advantage with the Docker containers. This example is for advantage with the Docker container. So right, so now here I don't bother about the container is running on the local machine which is running or not, or the it is not the configurations and other stuff. Simply a container is common to everyone. Right. So now the just what they need to do, they need to follow some instructions. I'm going to give the I have prepared a PPT. So now on the PPT, I have given the instructions so that simply they are going to follow that instructions to set up the code coverage like this. That people will ask in our interviews where exactly you have used the Docker. So one is you can say like our microservice deployments. What else? So this is an example for us case. So my team wants to have a song like code coverage on the local mission. So for that we have set up this song cube stuff. Yes, code quality coverage check on the local mission. So this is the PPT I have prepared for them. Just simply they have to follow the steps. That's it. So these steps are common to everyone. So once they follow this, like 4 to 5 steps are there, then finally they are going to get the result, something like that. Right. So now here I don't want that. I am not going to bother anything. Simply they have to follow the instructions. That's it. Likewise, the Docker is a classic example for this. The containers are. So then let's go to our Docker again. Right. So here when I'm going to compare my Docker with the virtual machines, right? Right. As I said, the Docker is a lightweighted server. That is common. Right? That is common in the sense that is usual. Like they are going to eliminate the other unnecessary components from the OS so that the machine will become a lightweighted. Later on, if you want, you can install it. That's the option they are going to provide it. So here again, in the lightweight in the sense, the resources, the resource utilization here. Right. So now here, how the Docker is going to utilize the resources. Right. So if I take a virtual machine, right? So virtual machine is nothing but we are going to have a mission, a server here. Suppose if I'm going to launch a Linux mission, a Linux virtual machine on my Windows laptop. So what I will do, I'm going to install the virtualization on this mission. With the help of virtualization software, we can create a new servers, a new missions on your Windows laptop with the help of the virtualization. Virtual box, as an example, you can take it as a virtual box, a kind of virtualization here, right? So now here, what exactly happening will be happening here? Whatever the server here, I am going to talk about server means you can treat your laptop as a server. You can take out, you can take it our desktop as a server. Right. So now here on the server, we are going to have the host OS. The host OS is nothing but if I take my laptop as a server, Windows is the host OS. On the Windows, we are going to install the hypervisor. Hypervisor is a software to create the virtual machines. So now here, if I want to have a separate machine, why the virtualization I need to do? Right, before going to create the virtual machines, why should I go for the virtualization? Again, the cost, right? So now here, a simple example here. So now here, I have my application, something like my Braille partner is an application, which is nothing but the loyalty program, card swiping, and the points are gaining something like that. So now here, I want this application should be run on Windows and as well as Linux also. It should not be any OS dependent, right? Otherwise, what will happen? Indians are going to use the Windows as an example. US folks are going to use the Linux. If I'm going to develop an application which is going to support only the Windows means US people cannot use my application. That is a drawback, right? So if I want to make it the global means it should support any OS like Mac, Windows, any OS it should support. Right? So now here the application is developed in such a fashion like it is going to support all kind of OS. How we are going to prove it? Right? How we are going to prove it means I need to test it. I need to take a Linux mission. On the Linux mission, I'm going to launch my application and I will see all the options. And in the same fashion, I'm going to take a Windows mission. I'm going to deploy it and I'm going to verify all the options, whether it's going to go, the flow is properly working or not. In the same fashion, Mac also, right? So now here to test this application for the OS support, suppose I require 3 missions here, 3 servers. It's costly for me. Purchasing 3 servers to test the OS compatibility. It's costly for me. So now here the other solution is you don't require to purchase 3 individual servers. Instead of purchasing 3, you can take your one server with some good configuration. On that server can be divided into multiple servers. Right. So now here, suppose if I take one server cost is 1 lakh, Now to check the OS compatibility, I need to spend 3 lakhs. So now instead of spending 3 lakhs, you can take 1.5 lakh server with good configuration. That 1.5 lakh server can be divided into multiple servers. Now here half of the amount is saved for me, right? So that's like what is an example for the virtualization. Likewise, when I want to have a servers, I don't need to spend amount of money to create a new to create a new server then do the task. Simply can take your own mission and create into multiple servers. So that's what the virtualization we are going to call, right? So now here, when I'm going to set up the virtual missions here, so now here I'm going to install the hypervisor on my host OS. By using the hypervisor, we are going to create a individual missions like this. So now the guest OS is nothing but your virtual server OS, virtual machine OS, right? So now here, as I said, to check the OS compatibility, then what I'm going to do, I'm going to launch a mission here with the Windows OS. I'm going to launch a new mission with the Linux, with the Mac, like that. The base will be the Windows, but these mission will be the guest server. The virtual servers will be having their own OS, like this. Now deploy your application, then do the testing. Right. So now here the resources, the libraries, the bins, these are the resources will be the separate for each and every mission. Means this mission will be having their own libraries. This mission will be having their own libraries. There is no dependency on any server or to your host mission. Every mission will be having their own resources, not in a sharing mode or not any dependence mode. Right? So that's what the virtual missions here. So now here, when I'm going to talk about the containers, one second. When I'm going to talk about the containers here, process will be the remain same, nothing but we are going to have a server, nothing but my laptop is a server. On the server, I'm going to have the host OS, nothing but my Windows. Then here the hypervisor we are going to install here, the Docker engine we are going to install. Docker we are going to install. With the help of the Docker engine, we are going to create n number of containers here, like this. These are all the containers, like the VMs. Now here these missions, these containers are lightweighted. That is the reason. If suppose if I'm going to create a mission, is a new server, a new virtual machine, it will take minimum of three. Like the OS will be 1.5 GB of OS. The image size will be, and minimum suppose 500 MB or something. Some RAM is going to occupy to create a machine here. Right. So now here in the Docker, hardly will take in 10 MB, 20 MB like that. The size hardly will take 100 MB. Here it is a 1.5 GB. It will take hardly 100 MB like that because of the lightweighted thing. Right. So unnecessary components are removed so that it will be lightweighted. Now with the one virtual machine, I can create minimum 4 containers here, 4 servers with the one virtual machine configuration like that. Then here the libraries. When I'm going to talk about the resources, the libraries, here every virtual machine will be having their own libraries, but here these containers are not going to have their own libraries. Instead of, they are going to share the host machine resources. Whatever the host are means, my Windows machine resources are going to share to the our Docker containers, sub containers, OS and upload libraries. I should share the OS and the where the libraries. The OS and the libraries are going to share by your containers. Right. So now here the thing is, these missions are the isolated missions, and the resources will be their own. Here these missions are the isolated, but the libraries and the resources will be sharing to the host server. So now here the problem with the Docker containers here is, if my server is Windows mission, right? So now here I can create the Windows containers only because my Windows resources are going to share to the containers. If my server is running on the Linux, then I can create the Linux containers only, right? Because the resources are going to share to the containers. Here it's a Linux or Windows. You can create any kind of OS mission. no dependency, no sharing. So that's where containers are not going to replace the virtual machines. Someone will ask, is the container going to replace the virtual machines? No, the virtual machine will be remain the same. Your containers are not going to replace any virtual machines because the resources stuff here, right? So here the problem, right? So now here, if you want to have the Linux, if it is running on Windows, that is a problem for me actually. But we have some alternative ways are there to have these missions also. But as a default, as a base, as architecture wise, yes, this is the problem with the Docker containers, the containers, because they are going to share the server, the host machine resources. That is the reason you can create the OS compatibility containers only. If it's Windows, Windows missions. If it's a Linux, Linux. If it's a Mac, Mac containers like that. So right guys, so this is about our containers and this is about our virtual machines. So what is the difference between the virtual machines and the Docker containers? Right. So what is the drawback? You cannot say the drawback, but it's a minus for the Docker container, nothing but the sharing of the resources. Right. So the advantage is lightweighted, on-fly, you can create n number of missions. With the one virtual machine configuration, I can create 10 containers like that. Like that advantage the Docker container. So now here where I can use, anywhere you can use. When you require a server, you can use the Docker container. You don't require to have a physical machine or virtual machine. Anywhere. Right. One more example here. Right. So usually this is the question for us actually. Right. In your project, what are the areas you guys are using the Docker containers? One is the microservice management. Like the second example, you can give something like this to check the local stuff, local code color. And the third one here is, if you guys observe, Jenkins pipeline, right? If you observe here, this point of I forget to tell you in our Jenkins stuff. Pipeline advantage, right? So what is the advantage with the pipelines? If I when I right, so when I have the pre-sale jobs, why should I go for the pipeline? Right? The advantage is, one is faster execution, correct? So when you compare with the freestyle, your execution will be the faster. The second one is logs checking. Logs, right? The console output. In a freestyle, you are going to see the complete job information in the console output. That job means all the steps. When I say take the pipeline, you are going to see the pieces as a pieces, nothing but each stage, each step will be shown the respective logs. You don't need to bother about all the log stuff. And the third one is multi-branch pipeline, right? So when I want to have a job for each branch, in the freestyle, I need to create a separate job. But here, simply you can place the files in the branches. Automatically, your pipelines are going to create the n number of jobs based on the branches. And the fourth biggest advantage with the pipeline here is, I forgot to tell you this point, guys. So now here, if I take my CA process, these are the two checks actually. One is, if your code is failed at the unit test cases execution, when there are failures in the unit test cases, then obviously you should fail the job. Or if the sonar cube quality gate is failed, then you have to stop the job. Right. So now here, suppose as an example, if my unit test case execution is taking like 45 minutes or 1 hour as an example, then this solar cube stuff is taking 45 minutes. So then I need to wait for at least 1 hour 45 minutes so that I can confirm my job is going or not. Or at least 1 hour. Forget about the 45 minutes in the least case. 1 hour, because if the job is failed at the unit test cases, then means in the 1 hour span only the job is going to fail. If the job is succeeded at the unit test case phase and it failed at the sonar cube, then 1 hour 45 minutes. Then only I can confirm like my job is succeeded. Otherwise, it is a failure for us. Right. So now here I want to minimize this time execution. Right. So then the next process will be after that sonar cube coverage. Then the next process will be your creation of artifact. Then push the artifact into repository. Then email notification. Suppose now all these three steps. Suppose it is taking of time. Or suppose again 1 hour. So now here my total job completion time will be 2 hours 45 minutes. It's a huge time for me. I want to minimize this time. At 2 hours 45 minutes, I want to minimize it. So then what we can do here is, if at any case either the unit test case or SonCube are failed, then stop the job. If both are passed over, then we are going to go for this next process. Right. So now what we can do here is, instead of doing all the stuff, so I am going to run these two steps parallelly. Right. So likewise. So now here I'm not going to run in a sequential mode. So now I'm going to run it parallel, so that max time will be for me 1 hour. 1 hour 45 minutes will be reduced to 1 hour. Right. If at any case if the job is failed, I'm going to stop here. I'm not going to proceed. If both are passed, then only it's going to go for the next process. So max time will be the 1 hour, because it's a 45 minutes job step. Right. So likewise, I can reduce the 45 minutes. How? By running the jobs in a parallel mode. Parallelly, right? In our freestyle job, you cannot run the steps parallelly, but in our pipelines, yes, we can run the steps parallelly. This is an example for us, right? So when there is no dependency, when there is no dependency between the steps, then those steps can be run in a parallel. Likewise, this is an example, right? So likewise, you can minimize the time. You can minimize the execution of the job, the total time execution of the job by running the steps parallelly, right? So now how we are going to run it parallelly? Right. Suppose if the machine is not having the sufficient resources to run the steps parallelly, right? So then what you can do here is, you can run the steps parallelly with the help of Docker containers, like this, right? So now here, how the steps are going to run in parallel means, you are going to, for each stage, this is the one stage, this is the second stage. Each stage you can have the agent section, right? So right, agent is nothing but where you want to run this job. That's what the agent, right? So now here usually if I give master means the jobs are going to run on the master. If I'm going to give my slave information means the job is going to run on the slave. That's what we have seen. So but here in our pipeline, we can run the stages separately on a separate server. Right. So this step can be run in a separate server. This step can be run in a separate server, the stage, right? By using Docker containers, like this. So now this step is going to run on the Maven, and this run is going to run the Java. Right. So now here I'm going to use the separate Docker containers. This is one more classic example of the Docker. Right. So now the pipeline step can have a capability of you can run the steps parallelly. Right. So now how we are going to run the parallel means, you can use the agent section for each stage. Now the agent can be your Docker containers. Right. So likewise, the Dockers can be used here also in our pipeline process also. Nothing but your CA process also. Right. So now, so let me go to our Docker, the Docker installation. Right. So now here, if I want to work with the Docker, right. So now here, like for Windows, you are going to have a different installation. For the Linux, it's Linux is our regular M command only, M install Docker, regular command. right? So now here, if I want to set up the Docker on your Windows, right? So now there is a software is available with the name called Docker Desktop. You can search for Docker Desktop. So that's Docker Desktop Mac Windows. Right? So it's like MSA file. Click, 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 go. Just download it and install it. Windows for Docker. Right. So now here, once you download it, then you are going to see the package something like this. Docker Desktop install.exe. This is the file you are going to get. Then simply what you need to do, you need to click on this exe file, then next, next, next. So automatically your Docker will be installed. So once the Docker is installed, you are going to see a Docker symbol on this tray. This is our Docker desktop. Once everything is fine, then you are going to see like this Docker desktop is running. So that you can run the Docker on your Windows machines also. You can create the Docker containers. Right. So as I said, the Docker is going to share or utilize your host machine resources. So that is the reason you can create the OS compatibility Docker containers. My machine is running with the Windows means I can create the Windows containers only, not the Linux. Right. But usually our practice and our real time will be the Linux only, very less than the Windows, like majority of the stuff in the Linux. Then what is the use of installing the Windows Docker containers here, Docker stuff here, right? So now here the Microsoft is providing a virtualization here inside the Docker. They are going to provide a virtualization for us, so that you can create the Linux Docker containers also with the help of that virtualization, right? So now here, right now here on the Windows machine is like ecosystem. It's not the Docker native thing. It's an ecosystem which is going to provide our Microsoft works, right? So now here, when I want to run the Linux containers on your Windows host machine or the Windows Docker desktop, then here right click. Once you install the Docker on the Windows machine, right? So right click on the icon, then a menu will be popped up or displayed. Here you can see a option called switch to Windows containers. By default, it will be switch to Linux containers by default option. Once you install the Docker desktop on your machine, the default option what you are going to see here is switch to the Linux containers. Means I have already switched to the Linux. That is the reason it is showing for me switch to Windows. But for you guys, once you install, you can see an option called switch to the Linux. Simply click on the option here so that the environment of the Docker will be switched to the Linux. Means the virtualization will be running in the background. So now it will be switched to the Linux so that you can create the Linux containers on the Windows machine, right? So now again you want to work with the Windows, simply come here and switch to the Windows so that you can work with the Windows containers. Likewise, this option is provided for us so that you can maintain, you can run, or you can practice both Linux as well as the Windows. This is the one thing which you guys need to focus here. So right, so now here this is the way of uh, launching or installing the Docker on the Windows machines. Simple, download, install it, that's it. So now when I want to install the Docker on the Linux, our Linux machines, right? So for that, what we need to do here is, let's take the Linux machine, services, EC2, so running instances, something is running here, start that mission, connect mission.
Shankar, it is saying PIM is not accessible.
I think it is down on the same location, not in so he is saying like with no such for directory. I think not, it is not on this downloads location. It is somewhere, I think. Okay, fine. Understood. So this message is not created on my laptop. From the some other laptop I created it. So let me start it. Usually the when we create a machine, right, on the same machine the key will be downloaded. So I have used some other laptop. That key is downloaded into that laptop. So that key is not available in my local in my current machine. So there is a reason it is not able to access it. So let me create a new server here. So Docker is not for means the Docker is not yet installed on this machine. So when you want to install the Docker on your Linux machine, simply the setup will be install Docker, install Docker only. So I don't think I have given the installation command here. Yes. So now here the command will be straight command yum. Yum install Docker. That's it. To install Docker on your machine, use install Docker so that the Docker will be installed. Service Docker status. So it is in inactive state. Let's start the Docker. So service Docker start. Now check the status. Now you can see the Docker is up and running. So now here Docker is going to give me the selection. Right. So now the Docker is ready. Right. So the installation will be the straightforward command yum install Docker. That's it. Then start the Docker service Docker start so that you can start working with the Docker. Right. So now how to start? Right. So now the Docker is ready. Now Docker is ready on my machine. Right. So now let's start working with the Docker. Means we need to know the Docker process. The process nothing but when I, as an example, guys, when I want to create a Jenkins pipeline, we need to understand the pipeline syntax, the sections. Then only can start working with the pipeline. In the same fashion, when I want to start with the Docker, I need to understand the Docker, the process, the commands, or the syntaxes, so that we can start working with the Docker. Right. So so that is the reason they have provided help for us to run the Docker. Right. So these are the commands which we are going to work with the Docker, which we are going to run with the Docker. Right. So now here Docker, suppose I want to run this Docker rm command. So now what I can do, Docker, then the command, then -help, so that you can see the Docker rm command help. Docker run. This is the uses and these are the options. And this is why what is the command here. So likewise, we can get the Docker commands here by running the Docker single the Docker enter. Then you can see that the list of commands. then you can get the each command help by running this docker, then followed by the command. What is the command you want to see? Then followed by hyphen help. Simple. The docker is very easy for very easy to learn and very easy to understand also. Right. So now let's start working with the docker. Like how the docker is going to work when you are going to run the commands. What exactly the docker is going to do for us. Right. So now here, before starting it, again I'm going to tell you guys. As I said, the docker is a pack, is a combination, right? So the combination is nothing but your server, a mission, along with the mission, the softwares and the configurations, and also application code also. Is a pack of all the stuff so that you can deploy a code, a application on fly with the help of containers. Right. So this is what the a simple form of Docker. So now here, when I'm going to run any command on the Docker, what exactly the Docker is going to do here? Right. So now here, the first thing will be when I want to start working with the Docker, I require a server. The server means my Docker container. Here we are going to call as a container. Container, but you can treat it as a lightweight server or a lightweight virtual machine. You can call it with the servers, but usually the practice is nothing but the Docker in the technical term. The technical term is nothing but Docker is nothing but containers we are going to call. Like in our AWS, we are going to call as instances. Right? Instead of virtual machine, we are going to call it instances, cloud instances. Likewise, in our Docker, the technical term is container is a lightweight server. Right? So now here, I want to launch a server means the Docker container here. But how we are going to launch? Right? To launch a mission, a container in the Docker, the command will be docker run. Run. So remember, the run is the command. The purpose of the run command is to launch a mission, launch a container. Which container you want to launch? Right. So now to understand better in a better fashion, they have given a sample container for us, nothing but hello world. How exactly the Docker is working, to understand in a better way, they have given us an example called hello world container. How exactly Docker is going to work, it will show us. So now here I am going to create a container for hello world. What is the hello world here? Hello world is nothing but it is a lightweighted application. So now here what will happen? This container is going to launch a hello world application for us. That's it. The hello world means. So now here let's see Docker run hello world I am going to run. So now what exactly the Docker will do? The first thing will be it is trying to search for a image, right? A image, right? So what exactly the image here is, right? So let's understand first this one. When I want to have a mission, nothing but the here in the mission means here now I'm going to call it the Docker containers. So when I want to have a Docker container to do my stuff, what are the components, what are the things are required for us here is to create a mission, the first thing will be we required a Docker image. Okay, so now how the containers are going to launch? With the help of the Docker images. With the help of the Docker images. What exactly the Docker image is going to have? So now the Docker image is going to have the platform and the softwares and the application code or application. Any configurations are there, you can have some configurations also. So these sections are going to have in the Docker image. The platform is nothing but which machine you want. You want a Linux machine, or you want a Windows machine, or you want to have a Sonar Cube, or you want to have a Java, or you want to have a Tomcat. That's what the platform is. Right. So now here, what you need a machine along with any softwares or any platforms are looking for. That's what here we're going to tell in the platform. Now suppose I required a Linux machine. So now I'm going to tell the platform is Linux, so that the container will be created with the Linux OS. Now on top of the Linux, I want to install the Jenkins, the software. Right. So now here in the Jenkins, along with the Jenkins, I want to deploy an application. Suppose a kind of application I want to run. That's my application code. That the Jenkins I want to run in the port 9090 configurations. Right. So likewise, you can have a Docker containers along with these sections. So who is going to provide these sections? Nothing but that these inputs to the Docker container, the Docker image. Now the Docker image will be having all the steps. So now who is going to prepare this Docker image? The person who is going to prepare the Docker image, right? So like now the DevOps are going to prepare the Docker images. We are the persons, or the developers are going to create the Docker images, right? How we are going to prepare the Docker images? So the Docker images are going to prepare with the help of Docker files. We are going to call it a Docker file. Right. So whatever the sections we are talking about here is these sections are going to place under this Docker file. These sections are. So now here, as right, either DevOps folks or the developers are going to provide the information, like the platforms information, softwares or the application information, entire informations are going to provide in the Docker file. Now this Docker file will be converted as a Docker images. Now this Docker image you are going to use to launch the Docker container. This is what the process for the Docker. Right. So now here, when I'm going to launch the Docker container means the Docker containers are required a input of Docker image. The Docker image having all the stuff. How the Docker image are going to build with the help of Docker file. So, right. This Docker file will be having all the code like our Jenkins file. How the sections are going to be there. In the same fashion, the Docker file, we are going to place all the code like with the syntax, with the Docker syntax. Then the Docker file will be converted into the Docker image. These Docker images are going to utilize to create the Docker containers. That's it, simple flow. Right. So now here, when I say, in my console, right, when I say Docker run hello world means, let me go here. Docker run hello world means hello world container I want to create. So now what the one, right, when I want to create a container, the container required an input of here the image. Docker image is required. Right, the Docker image is nothing but the pack. Right. So now here the containers are looking for the Docker images, so that with the help of Docker images, the containers are going to create. Simple. Right. So likewise here, if I go to our AWS again, exactly this is the what. When I'm going to launch an instance, it requires the first step will be the OS. Nothing but here we are going to call as a Amazon Mission Images. Right. So as I said here, right. So if I want to have a Python Ruby, then simply I can take this image. Right. This is the input for my AWS mission. So now the input is nothing but the OS. Along with the OS, I am going to have the software. The same thing here. This AMI can be correlated with here the Docker images. Simple. Docker images. Right. So now here, when I say when I'm going to run this Docker run hello world, then what the Docker will do? It will try to search for the image for the hello world. Unable to find the image. Right. So now it's going to try to search for the hello world image where on your mission, wherever the Docker run command is going to execute on the same mission, it is going to search for the Docker image is available or not. Means my local mission, my laptop. On my laptop, it is going to search for any hello world image is available or not. Right. If it is available, simply it is going to take the image from my local, from my laptop only. If the image is not available, then it will go to the community of the Docker. From the community, it is going to download the image into your local machine. Then with the local image, it is going to create the container. That's what the Docker is going to do for us. Like in our Ansible, that we have a galaxy. In the galaxy, we are going to have the roles. Correct? When I'm going to work with any role, simply I can take the role from the galaxy, download into my local, then I'm going to utilize it. In the same fashion here also, we are going to have a community called Docker. From the Docker community, it is going to download the image into your local machine. From the local machine, it will take the image and it's going to create a container for us. Right? So what is a community here? Like in our Ansible, we have a Galaxy community. Like for the Docker, we have a community called Docker Hub. We're going to call as a Docker Hub, the community. So let me show you the Docker Hub. The site will be hub.docker.com. To go to the Docker Hub, it is a storage, it is a repository for us to store the images. Right. So now here, when I search for hello world, it is going to search in my local, means my laptop. If it is not available, then it's going to download from the Docker Hub, from the community. And if I search it for the hello world here, you can see the hello world image here. Like your Ansible Galaxy, the same thing, right? Yes, you can see the hello world image. If I click on the hello world image, it is going to show us how to download the hello world image. We'll see this thing later. Just try to understand, guys. So now we have a hub. A community will be available. From the community, whatever the image you are trying to download, if it is not available on your local machine, it will try to get it from the community, from the hub. Then this image will be downloaded into our local. That's where you can see here the instructions. Unable to find the image locally. On your laptop, the image is not able to find. That is the reason it is pulling from the library, means the Docker Hub. From the Docker Hub, it is going to pull this image. So then once the download is completed, right? So now here you can see the status downloaded a new image called hello world with the tag latest. Tag means versioning. In our GitHub, we have the version, right? Tagging. So now here we can give the tags also the Docker images. We'll see. I'm going to show you each and every stuff, guys. Let's try to understand it. That's it. So now here, what happened here is when the moment I ran the Docker run means always create a new container. Run new container. That's it. That's what you have to understand. So now when the container is going to create, it will search for the input. Input means the image. So where is going to search the image? The image will be searched in the local. Then it is going to, if the Docker is able to find the image locally, then simply it will take the local image. Otherwise, it's going to download from the community. Then once the image is downloaded, then it's going to create a container. A new machine will be created. So now usually the Docker hello world, what the Docker hello world will be doing here is, it is simply a lightweight application, nothing but a display message. A message will be displayed. Hello from Docker. Means what they did here is simply they have written a code. Like it can be Java code or somewhat. So the Java code is nothing but a display message. Hello from Docker message will be displayed. So when the moment I am going to run the container, what the container will do, it is going to create a new container with the platform, suppose a Java platform. So now on the Java platform, whatever the code they have provided, the code is nothing but display message. The code will be taken and it will be executed. The code will be run. The code will be executed. So when the moment the code is executed, the code is nothing but a display message. The message will be displayed here. Then immediately once the code got executed, the container will be terminated. Right. So now the purpose is create a container and run the code. What are the code we have provided into the container? Run the code and terminate the container. Right. So now how the container will be created, what the code is executed, and right, what the container, how the container is terminated. That process is trying to explain here for us. This is the one. Right. So now here the steps. What exactly the Docker has followed. Right. Now the Docker client. Now here it is going to call as a client and daemon mode. Nothing but client is nothing but our Windows machine, our workstation. So now the client is connected to the Docker daemon, means our Docker hub. The Docker server. It's going to call it Docker daemon, Docker server, Docker hub, or Docker server. What it may be, our local machines are going to call it a client and daemon mode they are going to call. So now our local machine is going to connect to the Docker daemon, nothing but the Docker hub, and the Docker daemon pull the hello world image from the hub. It downloads the image into your local hub. See, from the Docker hub. Then the Docker daemon created a new container. Once the image is downloaded, then the daemon will be created a new container. That image which runs the executable that produce the output. Right. So now in the image, as a default, the code also placed. The code means application. Right. So now when the Docker container is going to create, the application will be executed. So that's what here executable that produce the output, nothing but here hello from Docker. and the Docker daemon stream the output into the Docker client, right? So now here client and daemon mode, right? So now Docker engine and the Docker container, the daemon will be sent to the output, then which is sent to your terminal. Stream to the output and send to your terminal means this is what. Then finally the container is going to be terminated. Right. So now here, right? So now here this is the process which usually the Docker is going to follow when you are trying to run the run command, Docker run command. Right. So now here I'm going to run the same command. As I said here, the image will be downloaded if the image is not exist on our local. Let's see. Let's try to run the command again, because here is going to tell us the image is downloaded. Download a new image, hello world. Now I'm going to run the, I'm going to create a new, one more new container for the same hello world. Now what will happen here? Let's see. Sudo -i docker run hello world. See here, no more download step here. Directly straight away you can see hello world message is displayed. Correct? That earlier we have observed that the image is not available, unable to find the image locally. That downloaded or pulling the image from the Docker hub, download the latest image, then finally, then after that we have seen this message. Now here means it has picked the image from the local. The image is already available in your local, so that instead of downloading again from the hub, simply it has picked from our local machine. That's what it's going to do actually. Right. So now here I'm going to tell us the container created, where the container is created. Now we are trying to understand the process. Now see where the container is created, where exactly I can find the images. Right. So now here to see the containers information, the Docker containers information, Docker ps is the command. Right. So now these are the commands, guys, which you need to remember. Very important for us when you are going to work with the Docker. When you are going means always maximum time we are going to spend with the containers only, because every application is migrating to microservice. Right. So now Docker ps is the command to see the running containers information. Running, right? So as I said here, the hello world container, what it is going to do here is simply it's going to execute the code and the container will be terminated. Yeah, that is the reason when I give the Docker ps command, I am not going to see the container information, right? So right, because the container is terminated. Now I want to see the terminated containers information, the exited, right? So for that, Docker ps -a is the command. All, both running and non-running containers information, right? So now here you can observe here image. What is the image here? Hello world is the image has taken, right? So now here you can see about a minute ago, just now we have executed one more time. This is the one, right? 15 minutes back already, 15 minutes back also we have ran the command of Docker run. So that is the reason you can see there are two containers are created. This is the one and this is the one. 15 minutes back, 1 minute back, right? It's exited. Once the code got executed, these containers are terminated, right? So what kind of code is executed in the container? To see this output, what exactly the command, right? The command is executed, nothing but here you can see hello is executed. What the command is executed inside the container, which is going to show here, right? Hello means usually hello.java file will be converted into hello.class files, the Java files into the class files. Then the class files are going to execute with the class name hello. That is the reason you can see here hello means usually it is a hello.java program. It is compiled. After the compilation, it is converted into hello.class files. When I want to give the class files, I need to give the class name hello. Right? That's what. Hence they are trying to execute. They are not trying to. They have executed the code hello. So that is the reason you can see the message here. So now here I am going to run the command again. Docker run hello world. Right? You guys need to remember, always it is going to create a new container. When the moment you are given the run, always it is going to create a new container for us. It is not going to take the existing containers. It is not going to touch any existing. right? So now here, right now we have two containers. Now I'm going to run one more time, means one more container is going to create. Enter. Right, it is, I can see the message now, docker ps-a. Let's see here, 9 seconds ago. Hardly how much time it has taken to create a new server? Seconds. Hardly 2 to 3 seconds. Right, that's what the advantage of the docker. On fly, you can launch a server. Right, connecting to servers, I will show you guys. Just I'm trying to understand the container stuff here. Okay, right. So the advantage of the docker is on fly you can launch a servers. Then on fly you can deploy your code. Right, the deployment also done here. I can see the my code also, the execution of the code. Right. So that's what the docker, a package, a container here. Right. So now here, how many times you are going to run the command? Those many times the containers are going to create. A new containers are going to create. Now all the containers are taken as the same image called hello world. Right. So now how I'm going to see my images information? Docker images is the command. Right. See here the size, lightweighted, means very less size. That is the reason on fly the machines are going to create. See 13.3 KB is the size, not even MBs also. Right. This particular mission, the particular server. Right. So now here you can see the image, the name is hello world. Right. So this image is downloaded into my local. That is the reason whatever the contents I'm going to create, it has picking from my local. First time, the first machine is not able to find the local. That is the reason it is downloaded into my local. First time. After that, the other two contents are picked in my local image only because the image is already exist. Right. So now here docker run is the command which is going to create a new container. Docker ps is the command to see the running containers information. Right. So docker ps-a is the command to see both running and non-running containers information. Docker images is the command to see the images information. Three commands. Right. So let's see the other commands of the docker. So this is the command, right? So now here every container is going to tagged with a container ID. Right. So now here if I take a virtual machine, right? So now here suppose again the best part will be the our cloud only. Right. So if I go to the AWS and if I go to the services of EC2, here I can say a container, sorry, a instance is running here. Now this is the ID. Usually for my instance, this is the instance ID. Now ID remembering is difficult. That is the reason we are going to provide the names. Right. So each instance will be having their own instance IDs. Likewise, in our Docker also, every container will be having their own IDs called container ID. So this is the container ID. This is the container ID, and this is the container ID to identify the containers. Right. Container IDs remembering is difficult, so that we can give the container names also, like our Windows, sorry, what is called AWS instances. How to provide the names? Okay, we'll see later. Right, try to understand that each container will be tagged with the container ID so that you can recognize the containers with the help of container IDs. Right. So now here I want to see only the containers IDs. I don't want to see all the stuff. Simply I want only the container IDs. So now for that, quiet mode. Q is the option to see only the container ID information. You don't want to have all the stuff. You want to have only the IDs. For that you can use quiet mode. Q hyphen A for to display both running and non-running. Q for to display the quiet mode is nothing but just to see the container IDs. Okay, it's kind of shortcut. So now here, this is the what. This is already covered. PS hyphen A, PS Docker run we are seeing. So then here, when I go to my Docker hub, I have shown you here the Docker hub stuff. Right, here you can see all the images information in the Docker hub. Right, so when I want to see the specific Docker image, simply go for the search and give the name of the image so that it will display the available images information for the name, whatever you're searching for. Here these are the hello world images. Right. So now here the same thing I want to see, I want to check from my terminal. from my command line mode, not from the GA. Right. So now, like your Ansible playbooks, right? Ansible playbooks can be searched from the CLI mode or from the GA. Go to the Galaxy and search it. Otherwise, you can search from the your Ansible also, like from the CLI. In the same fashion, if I want to search the images from my CLI, then the command will be docker search is the command. Then what you want to search? I want to search for hello world. The same thing. So whatever you are trying to search here, the same thing you can observe here also, on the GUI also. Like hello world, kitematic hello world, nginx, hello world, kitematic hello world. The same thing you can find it here. Right? Two ways. One is from the CLI also you can search for the image so that you can confirm, okay, image available so that I can create a container. Or go to the GA, go to the hub and search for it. Right? Which is the feasible for you, you can go with that. It's not like just follow the CLI only. Right? But yes, we have a command. A search is available. With the search, you can search for the images. Right. So then, right. So then here, I would like to create a container. Right. As of now, we have seen creating a container with the help of run command, but the container is not available for us. Right. So, but then what is the point of creating a container? Right. So if the container is not available for me, then my requirement is not like to just to go and execute the pro code. I want to connect to my mission, then I want to do some kind of operations when I need, then I'm going to execute the code later, something like that. So now when you want to perform the operations, then you require the container should be alive. It should not be go for the termination. If it's not available, then I cannot perform my operations. Right. So now here I want to have a mission. The mission should be alive so that I can connect to the mission, then I can do some operations on the mission. Mission means here container. Right. So now here for that, we have a command called execute to connect a container. So before connecting the container, just first create a mission, then what you call, then go for the connecting to the mission. Right. So now here to create a mission, the mission should be in a running mode. Right. So now here for that, what we can do here is docker run ubuntu. Right. So now here when I say ubuntu, right, so now what the docker will do, it will try to search for the ubuntu image. Right. So now here if the image is available, then it will download, sorry, if the image is available in the local, simply to take the local image and it will create a container for us. If the image is not available in the local, again it will go to the docker hub, the community, and it will download into local, then it will create a mission for us. Right. So now here when the moment I ran the docker run ubuntu is nothing but the image name. What are the image you want to take it as input for your container. Right. So now let's see. Right, the image is not available locally. That is the reason first time it is going to download from the docker hub, downloading the image. Right. So now let's see docker images. Right. So to see the image information, the command will be images, docker images. Now you can see there are two images. The one is hello world, right, and now the second one is the latest one, ubuntu. See, hard disk size is 73.9 MB, right? If I take the ISO file for the virtual machine, it will be 1.5 GB. That's for the Docker advantage. So now here, Docker PS. Still, I am not able to see the running container information. Docker PS-A. There are 1, 2, 3, 4 missions are there. Out of 4, these 3 are from the hello world, and this is the one just now I have created 47 seconds ago. Right. So now my intention is just to create a mission and not to terminate it. I want to have Ubuntu server. On the Ubuntu server, I want to do some kind of practice. Right. I want to practice my Linux commands. Right. So now here how we are going to do if the mission is terminated. So that is there we are going to use options. We are going to use the options along with the commands so that we can keep the mission alive. Mission means here the container, right? So what is an option which we need to use to keep the mission as alive, right? So now here the option will be the daemon mode or detached mode. -D is the option which we are going to use to keep the mission alive along with the run command, docker run command. So right, so now here I'm going to use docker run -D Ubuntu. So now here I'm going to tell my docker run command, nothing but create a mission and run in the background, daemon or detached mode, run in the background. So now we can see here a ID is generated, right? So now here docker ps, right? So now still the container is not running in the background, even though I have given the detached mode. Docker ps -a, I can see this image is, sorry, the container is created, it is exited, right? So now here D is for to run in the background mode, detached mode, right? So now to connect to the container, right, I'm going to tell my container like the to, I'm going to tell my docker to create a container run in the background, but I'm not going to tell that once the container is created, provide the shell and the interaction mode also, so that people can connect to the container. Just I have mentioned that just create a container on the background, right? So because of the shell and the interaction mode is non-availability of the interaction mode and shell, the container is not running in the background. So now here I'm going to tell run in the background mode and provide the interaction mode so other people can connect, and provide the shell also. Shell means the bash, right? Once the user is created, at the end you're going to see bin bash, correct? So right, so the shell also has to provide it, right? So now here to provide in the interactive mode and shell, now I'm going to run docker run -D for the daemon mode, I for the interaction mode, T for the terminal. So these are the options which we are going to provide so that the machine is going to run in the background mode. Then Ubuntu, Docker PS. Now see, right, a shell is provided, bin bash, right? So now I for the interactive mode is provided so that we can see the Docker container is running in the background. Right. So right. So now here, now up until now we have seen how to create a container. Now we are going to see how to keep the mission alive. Mission means the container, so that you can connect to the container, you can do whatever you want to do, right? So now here providing the control to the people, so that whenever they want to have a mission, they can on fly, they can create a missions. This is the what. So that when they want to create a new mission to for the practice or for the testing, simply they are going to run this command, docker run -dat, then followed by whatever the mission they are looking for. Right. So now here they don't need to connect to the ops team and raise a ticket. Simple, right? So anyone can create a mission on fly. So now here, once the mission is available, right, I want to connect to the server, right? I want to connect to the server and I want to do some kind of practice as an example case, right? So now here, see now here, right? So now here, this is my Windows laptop, right? Now the Windows laptop is connected to my AWS account. From my Windows, I connect to my AWS account. From the AWS account, I have launched my Red Hat mission, CentOS mission. So now here from the Windows, I have connected to the Red Hat mission by using the AWS. So now on the Red Hat mission, I have created a Ubuntu mission. Let's say Windows to Red Hat, from the Red Hat to Ubuntu. Let's see here how the technology is changing. Right, on the same mission, you can create n number of servers, something like this. Right. So now here, now I'm going to connect to the Ubuntu server now. Right. So now to connect to the Ubuntu server, now here it's not a physical mission or virtual mission. It's a simple Docker lightweight container mission. Right. So now Docker execute is the command. To connect your Docker containers, the command will be Docker execute. Right. So now when I'm going to connect the mission, I need a terminal and I want to connect in the interactive mode. So for that, the options which we are going to use here is Docker exec hyphen I and T, right? Interactive mode and the terminal. You don't require to give the D. D is for to only to run in the background mode. So the D is going to utilize only with the run command. So now we are going to connect to the running containers. Right, already the container is running. I'm going to connect to the running container. So for that, Docker execute hyphen IT. Right. So now here, what is the mission? Which mission you want to connect? Because there might be, you can see there are hundreds of containers are running. As of now, only one container is running. But going forward, if I create n number of servers, n number of containers, now you are going to see a list here, something like that. Out of all the containers, which mission you want to connect it? Right. So that's where we are going to provide the container ID here. Right. So now here, what is the shell? My shell is bin bash. Right. Terminal, I want to connect to the terminal, right? What's right? Which shell you are going to use? Bin bash. Enter. Right. Now you can observe here. Right now I'm with the 83 IP, nothing but my AWS instance. Now I connected to some ID here, nothing but it is a container here. Right. What is the ID here? The container ID only. You can observe here A636 something like that, right? So the container ID you can see here. Now see ls. You can see some directories here. So it is a container stuff here. Right. So now here from the Windows to I have connected the Red Hat machine of AWS. Now from the Red Hat machine to I have connected the Ubuntu server of Ubuntu container here. Now it is separate server. Right. So now here I cannot use M because it's a Ubuntu machine. M command not found. Right. So now here apt. See, you can see it is going to show the list. Right. So now here I want to do some practice with the Git as an example. Right. I want to practice the Git. So now here by default I have taken the Ubuntu platform. Ubuntu platform is going to provide a plain vanilla mission, a plain Ubuntu OS mission. Right now, if you want to practice, you want to install anything, you can install it. That's what the container advantage here. You can have a lightweight server on the server. If you want to install anything, you can install it. Right. So now here I am going to install the Git. I want to do some practice with the Git, so I want to install the Git. So now here what I will do, apt is the right for the Ubuntu apt get or apt update it, apt update the packages, then apt install git. Now git is ready. 2.25. You can practice the git. Likewise, right? So it's a server, as I said, it's a server, a lightweight server. On the server, if you want to install it, you can install it and you can do whatever you want to do. Right? Or else from the platform, while choosing the platform, you can tell like I want to have all the setup. So that your platform, while creating content, your platform, nothing but your image will be taken care of all the stuff. Right. So now here with the container, with the Docker, with the containers, we have a problem. The problem is Docker containers are stateless. Docker containers are stateless, means it is not going to maintain any state. Right. So let me go to the diagram again. Right. If it is it is a virtual machine or a physical machine. Right. So now here right, if it is a virtual or physical machine, you're going to have hard disk, so that whatever the applications or whatever the softwares you are going to run, the content you can store in the hard disk. Later on you can utilize it, but for the containers you are not going to have any kind of space. It is not going to have any space. It is not going to maintain any state. Right, you can maintain a virtual machine state on the space, hard disk space, so that later on you can utilize the space and you can take the state as well. Right. So like here, but here in the containers are stateless. It is not going to maintain any state. Means suppose if I have some contents here, some files, I have some downloaded some files here, some packages, something like that. right? So now the container used using the platform Ubuntu, right? So now this container uses the platform Ubuntu. Then once the container is created, I have to place some files and packages, something like that. As an example here, my Git as an example, right? So now here with the reason the container got failed, right? So now on fly we can create a containers on fly, right? Within seconds. Within seconds you can create a new missions. With the Ubuntu, because Ubuntu is the image which is available in my community, right? I can take the Ubuntu image, then I can create new content. But the problem is the contents, the files and packages are not going to get, right? Because these are the containers are stateless, they are not going to maintain the state. Now the problem is this is the one. This is the major thing which you are looking for actually, right? So if I am not going to maintain the same means, what is the use of using the content? I can go to the virtual machines. Maybe it will take 5 to 10 minutes. That is fine for me. Still, I can have the space, content. But here, if a content is not going to maintain the state, then it's a problem for me. Right. So for that also they have provided to maintain the state. Maintain the state means the content you can maintain it. Right. So that you can create the new content along with the state, like the hard disk space, something like that. Right. So we'll see. I will show you that one how to maintain the state. But usually the default behavior of the contents are stateless. They are not going to maintain any state. If you are trying to place the content inside the container, if the container is gone, you cannot get the content back. Simple. Until unless if you are not managing the content in a separate area, nothing but the backup. If you are not managing the backup, you are not going to get the content back because the contents are stateless. This is one point. One more point, guys, for us. Okay. So I will show you how to maintain the state and other stuff. We'll see. We have a separate comments for that. But this is the one concept, one point for the Docker. So now here, let me go back to our containers again. Right. So now likewise you can go to the containers and you can connect to the containers. You can do whatever you want to do inside the container, then you can come back. Right. So now here sudo -i, then docker ps. Docker ps. Right. So now here you can see the container is running 10 minutes ago. Docker execute -80 and the container id, then bin, right? The command bin bash. Now I connected. Now if I have to see the git, still I can see the git because the container still exists. It is not terminated. Right. So to come back, to come out from the container is exit is the command which you are going to use to come out from the container. Docker ps. Right. So likewise you can maintain, you can keep the mission running, keep the mission alive until unless you terminated it, or with the reason the container is terminated, with some of the reasons, right? So right, until that point you can use the container, then whatever the stuff you want to maintain, you can maintain it, right? So this is the command which we are going to use to run the mission alive after the container is created. Nothing but docker run -d it, right? So now here, once the container is created, docker execute -it is the command to connect to the containers. Right. So now let's go here. Now, if you guys remember, in our Ansible, if you want to see the properties of a mission, right, of the virtual mission, I want to see the properties. For that, what we have used is setup. Setup is the module which will display all the properties of the particular server. Right. So likewise, here also in the Docker, I want to see the container information because the container is also a server. I want to see the IP address of the server, right? I want to see the other properties of the server, nothing but the container, right? So for that, Docker inspect is the command. Inspect is the command which is going to display all the properties of the container. Which container? What are the container you're going to provide as input to the inspect container, inspect command. Now here I have only one container. So now this container properties I want to see. So Docker inspect, then the container ID. Enter. Right, you can see here a bunch of properties, nothing but the our server information. ID, created, shell, state. Right now it is running. The other properties, parser and other stuff. Likewise, if I scroll down here, the image, our image ID, nothing but the Docker Hub, Ubuntu image. This is the image ID, the image information, and likewise here you can see the platform. As I said, the platform is the Linux platform, right? And if I go here, network information, CPU count, graph driver, mounts, configurations, environment variables, command. By default, what is the command? Image. This is the image we have in Ubuntu, and this is the network information. Here you can find the IP address. IP address. This is the IP address of the server, my container. Right. So if you guys remember again, whatever the instances I am going to take, whatever the instances I am going to take here, right? So those instances we are going to convert into web servers, app servers, DB servers, RO Jenkins, build machine, so whatever, right? So this is a plain machine, and later on we are going to utilize this machine as for our purpose, right? So now here if I go to the deployment process, right? For the deployment, I required a server. On the server, I required the Tomcat to deploy my Java application. Then I'm going to deploy my code. That's what we have did, right? In our previous project, in the CI/CD process, we are taking a new instance. The instance is converted into Tomcat server, nothing but the web server. Then deploy the content. Right. So now here, once the content is deployed to access the application from the server, from the web server to access the application, we have taken the IP address, correct? IP address of the server. Suppose if it is a Tomcat server, then we have taken the IP address of the server, then colon the port number. Default port number of the Tomcat is 8080, then slash the application name, like Game of Life. That's what the syntax. Your IP address as the host name, then colon port number, then slash application name, right? So that you can access the application which is running inside that particular mission, right? So now here, this is also container is also server. As I said, the containers also can be treated as a server so that you can work with the server, right, based on the requirement. So now here I want to deploy the application to the server. Server means here the Docker container. So now I want to access it, right? What are the application running inside the container? I want to access it, right? So now here usually if an application is running inside the virtual machine, nothing but the AWS instance, we are going to take the IP address of the machine, then we are going to use the IP address followed with the port number. Suppose Jenkins, IP address followed with the 8080 to access the Jenkins. But for the containers, we cannot use the IPs to access the applications which are running inside the containers. We cannot. So this is the point you need to remember, guys. So whatever the applications, whatever the softwares are running inside the container, those cannot be accessed by using the IP address of the container. We cannot. IP address of the containers are for the internal purpose only. For the internal purpose only, this IP address are going to use, not for the external purpose. Then how we are going to access the applications which are running inside the container? That is a different command which we are going to use. We'll see that one also. Try to understand, guys. The IP address will be there for the each and every container, but we are not going to use the IP address to access the applications or the services which are running inside the containers. Right? Only this is for these IPs for the internal purpose. The Docker is going to use for the internal purpose. Right? So now here, let me go to the PPT again. -w, right? So now while creating the container, we are going to use some options for our in our day-to-day life, so that we can achieve the things faster. Okay. So now here in those options, one is -w, nothing but working directory. Working directory here. Right. So here, if I go to my container, let me connect to the container. The container is gone. So let me connect to the container. Docker ps. So this is the container right now running, correct? So now to connect the container, now you know the command is docker execute exec, then interactive mode and the terminal, then followed by the container ID, then followed by the command. Nothing but the bash, bin bash. Right. So now here, let's see the working directory pwd. We are going to see the slash main location, correct? So now here, by default, your container will be connected to the main path slash. Now here I want to change the working directory. I don't want to have the slash. I want to change the working directory of the container once the container is created. Right. So that's where the option is -w. -w is nothing but to change the working directory of the container. Right. So docker run -w. Right. So let me show you. Docker run -dit. Right. Run means create a new container. Then -w. I want to change to Shankar and my image is Ubuntu. Ubuntu is the image means Ubuntu container I want to create. Right. So now here -w. So something what W means working directory DIUT and Shankar Ubuntu. Okay. So I am inside the Docker container. That is the reason Docker command is not found. Come back. Come back from the container to your virtual machine. Now try to run the command. Right, so here slash has to be provided slash Shankar, right? Don't give the Shankar, which is not taking here. So now let's try to see Docker PS. Now we should see two containers, right? So now this is the one just now we have created, and this is the one 21 minutes back we have created. Now try to connect it. Docker execute -it, then bin bash. Now see, default working directory switch from // to whatever we have provided here, pwd Shankar. Right here, what the Docker is going to do here is, if the path is available, if the path is exist, whatever you are going to provide here in the -w option. If the path is exist, it will take the path. If the path is not exist, it is going to create for us. It won't throw any error for us. Simply it is going to create a path for us. If it is already there, it will take it. Otherwise, it will create it, right? Shankar is not available as a default slash Shankar. Automatically, the Shankar is created for us. Your Docker will be taking care of that one. Right. So likewise, the default working directory can be changed with the option called -w. Right. So now here the thing is to confirm it, to check this one. Right. So to check whether the working directory is switched or not. Right. I have given a command called docker run so that the container is going to create. Along with the docker run, I have passed the option called -w so that I want to switch the default working directory to my custom working directory once the container is created. Fine, that is fine. For that, I have given the option. Later means once that run the container is created, to confirm whether the working directory is changed or not. For that, what we have done is we have switched or we have connected to the container which was created. Then we have passed the command called present working directory so that we confirm that yes, it is switched. The working directory is switched from the default to my custom. So now to check this kind of things, you don't require to connect the container and run the commands. Straight away you can check it. Straight away you can check it. You don't require to connect to the container. Right. So this is multiple ways, guys. I am trying to tell you multiple ways how to achieve these things. But whatever is feasible for you, whatever is easy for you, go with that one. It's not like only we have to follow the same process. Right. So the other way, what we can do here is right here. Now here I am going to create a container with the directory name called DevOps. Right. So now here I am not going to run directly straight away something like that. I want to confirm it. Once the container is created, I want to confirm it whether the directory is switched or not. For that, what I'm going to do, pwd. Let's see whether it will work or not. Otherwise, I will show you the other command. Right. So now here I'm going to run pwd command, present working directory. So right. So now this pwd command is not working here. Right. So here it is right. Run means always create a new container. Always create a new container. Then dit run on the background, interactive mode terminal. Then working directory should be DevOps, and this is the image. Okay. It ignored this command. So this command cannot be used with the run command. That is fine. So now here docker ps. Now we can see. Okay, that's okay with the command. It is created, but it is terminated. So let me try to run the command and let me remove it. Now we can see there are 3 containers are running. Just now we have created 2 seconds ago. Right. So now here I want to see whether this container default working directory is switched from the / to DevOps or not. That for that what we have done here is we have entered into the container. Then we have ran the command pwd. Right. So now here to confirm it, we have connected to the container. Now here we don't require to connect to the container. To confirm it, you don't require to connect the container. Straight away you can execute. That's what the execute option here. The execute option is nothing but just not to connect to the container. You can execute the commands inside the containers. You can execute the command inside the containers, right? So right. So now what you want to execute here? So I want to execute a command called present working directory so that I want to confirm it is switched to the present working directory from the / to my custom. Right. So for that I don't want to connect it. Simply can execute it. Right. So now here what I am going to do here is docker execute. Then bin bash means it will try to connect the terminal. It will try to connect to the terminal. So now here instead of running the bin bash, I will pass the command called pwd so that this execute command will execute the command whatever you have passed it here inside this container. That's it. Enter. Now see, without connecting to the container, we have execute the command. That's what the option is called execute. exec, right? Right, guys. So likewise, we can we can execute the commands inside the running container with the help of Docker execute. So now here with the help of Docker execute, either you can connect to the containers or you can straight away without connecting to the container, you can execute the commands also, right? So right, guys. So let me take a break here at 12:30, right? We'll take a small break here for 15 minutes. Then we'll come back. Then we'll see the rest of the commands, right? Any doubts until now, or are we good? ఉన్నారా లేదా? ఏంటి? ఉన్నారా? Okay.
Looks good, Shankar.
Okay, cool, Chris. Yeah, thanks, Chris. Then yeah, fine, guys. Then we'll meet after 15 minutes, 12:45. Okay. Yeah.
Sure.
This conference will now be recorded.
Okay. Right. So now the other options along with the Docker run command. Okay. Right. So the one which is very important for is -p, publish or expose port number. Okay. So now usually, as I said, Docker container IPs are not going to utilize to access the application which are running inside the container. Like how we are going to use for the AWS instances or the virtual machines to access the application. So now how we are going to access it then? Right. So if we are not able to access into the outer world, then what is the use, right? Which is not useful for me, only for the internal purpose means. So now here the Docker is giving an option like you can use the port numbers. You don't require to use the IP address of the container. Instead, use the port number which is running the application inside the Docker container. Right. So now how we are going to use the port number to access the application into the outer world. Right. So for that, right. So if I take this is my virtual machine or our AWS instance. Right. So on this instance, we have installed the Docker. Suppose this is my Docker. So now here, whatever the containers I am going to create with the help of Docker engine. Right? Suppose this is my Docker container. This is my Docker container and which is running Tomcat. Right. So now here, this is my AWS instance. Right. On the instance, we have installed the Docker. So now this is my Docker space as an example. So now in the Docker, we are running the Docker containers. So now this is my container which is running with the Tomcat. So now if I want to access this Tomcat outside of the, right, like in the outside of the world, so then the Docker container of the Tomcat will be running with the port 8080. Now this Tomcat is running with the port 8080. So now here, suppose this instance IP 10.0.0.1, my AWS instance IP. So when I want to access this container application, nothing but the Tomcat into the outer world, then wherever the Docker is running, means on which machine the Docker is running, that mission IP has to be taken. So now my Docker is running on this AWS instance. which is nothing but the 10.0.0.1. So when I want to access the Tomcat container outside of the world, then I need to use the my host mission. Wherever the Docker is installed, that mission IP, then the port number of the application of the Docker container. Right. So IP is of the AWS instance where the Docker is running. Then the application port number we need to use 8080. So now here on my AWS mission, I have installed Jenkins. So now when I install the Jenkins, by default, Jenkins also use the same port 8080. Right. So now when I use 10.0.0.1 8080 means it is going to overwrite. It is going to ignore the container port. Instead of it is going to take the Jenkins. We are going to use the Jenkins. So now when I want to access the container application by the Tomcat, so there are two ways. One is change the port number of the Jenkins on the host machine so that you can access the Tomcat with the default 8080, or launch a new container with the port 8090. Apart from the 8080, use any port number so that now if I use 8090 along with the IP, then I can access the Tomcat. Right. So now how we are going to allocate this port number 8090 to this Tomcat container. By default 8080, that is fine, but a new port I want to allocate. Right. So now the allocation we are going to call as a exposing or publishing of the port -p. Okay. Right. So now here this -p is going to utilize nothing but whatever the default, right? So usually the default container port will be 8080, but I want to expose into the outer world as a 8090 because the 8080 is already occupied by someone, something like this. Right. So now here I cannot use the same port number. So now what I'm going to do, I'm going to tell that use this application by using the new port number called 8090, expose it or publish it into the outer world. That's what port number exposing we are going to call. The port number exposing option will be -p, Docker run -p. Then this is the right side one is nothing but the container port, and the left side one is nothing but the outside of the world. Right, in the outer world, how we are going to access it. Right. So now here, when I want to access the Tomcat in the outer world, 8090, but the default will be the 8080. Right. So now here we are going to tell map the port number 8090 to 8080 of the container. Right. So now here, this is the default one of the container, nothing but the Tomcat one. But into the outer world, I want to map it as some new port number so that I should not face any conflicts. That's what port mapping we are going to call, or publishing we are going to call with the help of -p, then the new port number. Anything can give it here. Then the original port like that. Right. We'll see with the example this -p. Let's just try to understand Docker run -p for nothing but the exposing of the port number, publishing of the port number. Hit -p. Then the left one is nothing but the new port number, which you want to map. The right side one is the default one for the container. Right. So now this we'll see with the example, just try to understand it. Now the second one is the other option is passing or configuration or setting up a environment variables inside the Docker container. Right, we know the environment variable setup, right? So Java home, we have set up the Java home, JRE home, M2 home, maven path, right? Many environment variables we have configured during our installation process of Tomcat or maven or Java, whatever. Right. So now is the container also a server, is also a mission. On the mission, if I want to set up environment variables, how we are going to use, how we are going to set up. That's what the option is -e. E for environment variables configuration or environment variables setup. Right. So now here, let's take this example. So now here Docker run, we can use -e or -env or -env file. Either anything you can use. Right, so here Docker run -env. This is my variable one. Right, so now here something like that. Suppose Java underscore home, where as an example where lib Java open JDK. Now one more variable you want to configure. JRE underscore home, where lib JRE, something like that. Like that. So now here, likewise, while creating the Docker container, if you want to set up the environment variables, -env is the option. Right, so now here, Docker run -dit. So that I want to keep this machine as alive. Enter Docker ps. 3 seconds ago, just now I created it. Docker execute -it bin bash. Execute -it bin bash. So now that if you want to see the environment variables, the command is env, correct? Env is the command which we are going to use to see the environment variables list, right? So these are the two variables I have configured just now, Java home and JRE home. So likewise, we can set up the environment variables, Java home and JRE homes, or whatever it may be, any environment variable by using -e is the option. -e or -env is the option to pass the environment variables to the container. Okay, that's so here the command which you guys observe here. Okay, I think we can execute the commands also, not only Docker run here. After Ubuntu, I am trying to execute the env command so that it's going to display all the environment variables. From that, I am going to grab the where is nothing but here var1 var2, the list to see that is the reason why you use this command. Otherwise, you can ignore it. You can run something like this. Okay. So now -env file, right? If there are one or two variables, we can set up something like that. If there are huge amount of variables, like 10 or 10 to 15 variables are there, then your command will become complicated. Right? -env1, -env2, -env, like that, you need to pass it. So now here to handle the situation, what we can do, we can put all the environment variables in a file. The file can be passed as input. Right? If there are less number, like one or two are variable, then you can pass by using -e or -env. If there are huge amount of list, then what you can do, we can create a file. In the file, you can place all of your variables. Then you can pass the file as a input. So suppose, so this is the file I'm going to create. Here env dot list something, some file name. The extension can be anything. So now these are the variable one, and this is my value one, and this is my variable two, and this is my value two. Save it. So now here we have created a file called env.list. In the list, we have our environment variables, or else what I will do, let me take this one. These are my variables. And some of these variables I want to pass to my container, Java home JLMPL something. Right. So now here you can use the option -env file, then you can pass the file name, so that you are going to create a new container along with your new environment variable list. Docker run -dit -env file env.list then Ubuntu. Docker ps 3 seconds ago. Docker execute -IT. So I'm not going to connect it. Simply I'm going to run the command env. But these are the variables we have configured: Java home, JRE home, and blah blah blah. Right. So likewise, you can use the -env or -env file options to pass the environment variables to the containers. Right. This is one more option along with the Docker run. Right. So these are the options we are going to use while creating the container. If you want to set up any default things, default configurations, these are the options. So now here, very important one again, nothing but volumes. Right. So now volumes are nothing but, as I mentioned, Docker containers are stateless. They are not going to keep the content statefully, nothing but always. If the container is gone with any reason, right, the reason can be anything, you are going to lose the content also, because the default behavior of the containers are stateless. Now in our real time, it should not be like that. You have to maintain the state, means you have to maintain the content, so that if the container is gone, I am going to create a new container, then I'm going to launch with the existing data, whatever was there in the previous container. Right. So now here, the concept here is this is my container. Container 1, and we're having suppose like a Java running inside, some files and application code, something like that. Right. So now here, because of the stateless mechanism, if I lose the container, I'm going to lose my files and application code. Right. So now here, suppose the application is running, container is running, then people are trying to push some data here. So the data is producing here. By the time the container is gone, I'm going to lose the data also. That anything, if you are placing the data, DB data, whatever the data you are trying to push into the container, if something is failed with the container, then you are going to lose the content. Right. So how we are going to maintain the state? So now for that, what we are going to do, we are going to create a separate space we are going to call as a volumes. Volumes. So now here what will happen? So whatever the data is pushing into the container, right? So now people are trying to push some data like application code or some files, whatever. So whatever the data is pushing into the container, that will be pushed into the volumes. Because something like that. So whatever. So now here you will be having the container along with the Java platform. Then these are the files and application code. People are pushing it. Now what are the content they are pushing? We are not going to store in the container. Instead of, we are going to place in a separate space called volumes here. So now here, it's with any reason, if the container is gone, right? So now here, what we are going to do simply, we are going to launch a new container. We are going to launch a new container with the dev platform, right? The platform is nothing but my Java, right? The platform will be available in the Docker Hub, right? You can take the platform like this. So now here my content is ready with the platform, but I'm going to miss the content. The state I'm not going to. Simply what I will do, I am going to map the new container to the volume. What are the volume I have created? What are the space I have created? So that it can consume the same data again. So that you are not going to lose the state. Likewise, you are going to maintain the state of the containers, the server. But otherwise, by default, stateless. If you lose means you are going to lose everything. To maintain this, you are going to create the volumes. Very important in the Docker area. Right. So now here, how we are going to create the volumes in the Docker. So for that, the command will be right? So you can create n number of containers. It's not like only one or two. You can create n number of containers, and the containers can be connected to the volumes, the same volume. All will be shared the same space. Right. So now here to create the volumes in the Docker, we have a command called docker volume create. So where these volumes are going to create, finally, it is going to use the space of your instance. Wherever the Docker is running, the machine space is going to take. Right. So now here, if my Docker is running on my Docker is running on my AWS instance. The AWS instance space you are going to take it as a value. This is my AWS instance. This space is going to take it. Docker volume ls is the command to see any volumes are exist already. As of now, no volumes are exist. This is plain. So now here I am going to create a volume. Docker volume created the option. Volume is the command and hyphen name, then followed by the volume or something. My volume. Now we can see my volume is created. So now I'm going to use Docker volume ls. Drivers will discuss later. So now here Docker inspect, right? The inspect command. What is the option? Use of inspect is to see the properties, the complete information. Right? The inspect command can be run on the volumes also, not only for the containers. You can run on the volumes also. Now here Docker inspect then my volume, so that I will get the complete details. Right? So what the complete details are nothing but where exactly the volumes are going to create on the host mission. But as I said, it is going to use your host mission space only. When I say the volume space, right? So what is the path? Right? This is the mount point in our host mission. Right? On the host mission is going to take this path. Here is going to store the data, nothing but my volume. Whatever the content I'm going to push into the Docker container, the content will be stored in the my volumes of the Docker volume. This my volume is mounted to your host mission path. Right? So if I go to the CD where lib Docker volumes, and here I can see our volume information, our Docker volume. If I go to the, like you can treat it as a folder. If I go to the, this is the folder subfolder which is going to handle the data, store the data. CD underscore data. As of now, you are not going to see anything because as of now, you have not attached this volume to any container. Means we are not saving any data. We are not producing any data into this volume. Right. So now here, if you want to see the volume details, right, simply can use the inspect command, so that you will get the mount path on your host mission. Right. So now I want to attach this volume to the containers, right? So that I want to maintain the state, correct? So now to attach this volumes to the container, then the option will be -v. Option will be -v, right? So now here Docker ps. These are all the running containers. Right, so now here I'm going to use I'm going to create a new container, and the container will be attached to our newly created volume. Docker run daemon mode -v is nothing but the volume mounting, right? So now here my volume is nothing but what is the volume we have created with the help of Docker run volume command, my vol, and inside the container, correct? Inside the container, what is the location which you want to map, which you want to mount to your newly created volume, so that whatever the content I am going to produce into the location, the data will be captured or taken into your mounted point, nothing but my volume, right? So now here inside my container, I want to mount this volume to data directory, so that whatever the content is going to place in the data directory, it will be saved into the my volume, right? So here, what is the image, right? As an example, I have taken the earlier Ubuntu I have taken. Now here Debian, right? Any machine you can create. Debian is the one we have taken. So the Debian is not available the default locally. That is the reason it is pulled out and it is created new container for us. Docker ps, right? So here the problem here is again we have used the -d only. That is the reason we cannot see the Debian stuff here. So here let me use -d, then it docker ps. So now here you can see a new container is created with the image Debian. Here the command is the bash for this bin bash. Here the command is bash, right? So now here we have said mount your content of the data directory or my volume, right? So now here I'm going to mount it. So Docker, already the mounting is happened. Now let's see nothing but the data is capturing or not, right? So now what I'm going to do, let me connect to the container. Docker execute -it, right? So here we can use bash, right? We have connected to the Docker containers. ls, now one directory should be exist with the name data, right? So this is what I have mentioned, data. So let me go to the data, ls. As of now nothing is here, correct? So now here we have verified the my volume also, right? The my volume also is not having any data as of now. Now I'm going to produce some data. Touch three files I have created inside my data directory of the container, right? So let me come back, exit. I had came out from my container. So now I'm in the host machine, my virtual machine, my AWS instance, right? So now here the location, right? So now I want to confirm whether this data has been copied into my volume or not, right? So now to confirm it, docker my docker volume ls docker inspect my volume, right? So now here in my host machine, this is the path where this my volume is mounted, right? Let me go to this path, ls. See, 1 2 3 4 are replicated. The data is taken back up into the my volume, right? So likewise now the state is maintaining, right? So now docker ps, right? So now whatever the data is producing into the data directory of this container, it will be taken into the my volume. Now what I'm going to do, I'm going to create one more container. Here I'm going to use Ubuntu now. Docker and -d. My volume I'm going to mount it to Ubuntu machine of the data directory. Docker ps. So now here one more machine is created with the Ubuntu, right? So now let me connect it. Docker execute -it, bin bash, go to the data directory, ls. See, right? The same data I can see here on the one new container, right? The same example, right? So I have created a container. Inside that I have placed the files. Now the files are taken into the volumes. So now I have created a new container. I have, while creating the container, I have mounted to this my volume so that whatever the data is there, I can see it here. The same thing happened here, right? Happened here. So now here, touch Ubuntu, right? This is the Ubuntu mission. For the sake, I'm going to create the Ubuntu.txt. Now here Ubuntu.txt, a new file is created. Right? Let me come back, and already I'm in the data ls. I can see and the Ubuntu, right, in my host machine on that other data. The ubuntu.txt has been taken. Now here docker ps. If I go to the Ubuntu, sorry, Debian server, docker execute -19 cd data, you can see the data, the other machine content also I can see because both are connected to the same volume. On any machine, if any data is producing, the same data can be seen on the other machine also. Right. So likewise, the state can be maintained. If I suppose now here I'm in the data, right, so I am going to create one more file in my location, my volume, like host.txt. Now here I have created a file code. Now it should be replicated on my new servers. On my new means on the servers, whatever the servers are mounted to this particular my volume. Right, so let me go to any one other server. Dot execute -it ls -data. Right. So here I can see how that is. Right. Likewise, the volumes are very important for us as a right. So in the Docker area, volumes are going to play a vital role here. Right. So like right, nothing but to maintain the data, the backing up the data, so that in our real time, what we are going to do here is we are going to deploy the applications into the microservice format. Now the microservices are nothing but your Docker containers. So in any with any reason, if the containers are died or terminated, we are going to bring up a new mission. We are not going to go and do the troubleshoot. Simply, we are going to launch a new mission. So now, while going to launch, it has to maintain the state. How we are going to maintain the state is we are going to take the volumes on the volume, the data will be pushed up. When the new content is going to create, simply are going to attach the volume to the content. That's it. So the same state can be maintained likewise. Right, guys? So this is one thing. So now once the volumes are right, so you don't want to maintain the volume, simply can delete the volumes by using docker volume remove the command. Docker volume remove and the volume name can provide so that the volume is going to remove. So then this is right. So here the maintaining the state of the container can be done by using the volumes. Create a volume, correct? Then attach the volume to the Docker container while creating it by using the option called -b. Now we have one more way to maintain the state, right? So the other way to maintain the state is nothing but you can use the existing path of your host machine as a mount point. Got it, guys? So now here the thing is create a volume, something like that, then attach the volume. This is one way. The second way is take any path. Take any path of the host machine, right? Host machine means my intention will mean nothing but my server, my laptop. On the laptop, take or your AWS instance, take any path. Suppose here I am going to create root mkdir DevOps ls. Right. So now here this DevOps directory I want to mount to my Docker containers. Right. So now it is not a volume, it is a directory of my host machine. This is the volume. The best practice is always volume, not the directories. But yes, we have an option of you can mount your directory of or any path of your mission as a mount point to the Docker containers. Right. Multiple ways. Right. For that, what we are going to do here is docker run -b, then the same thing, right? So your path and colon, then followed by our container path. Right, so here so here I want to mount my DevOps directly to my data of newly created container. Docker PS. This is the one just now I created 4 seconds ago. Docker execute -it. Right, we don't require to connect it, right? Execute with the help of execute, you can execute the commands, right? Docker execute, then touch. I'm going to create a file inside the data directory as a name, suppose shankar.txt, something. Right, so now here ls cd devops ls is not created. Docker execute -it bin bash. Let's go and confirm, see whether it is created or not. cd data. This file is already created inside the shankar.txt, sorry, data directory, but this DevOps one is not connected. So maybe we need to give the entire path. Let's see by giving the entire path here. Root DevOps, then Docker PS. 2 seconds ago, just now I created it. So this is the one just now I created, A9. Then trying to create a file inside that container. Let's see if it works or not. Yes, now see here, you can see the shankar.txt file is created, right? So nothing but here, what I done here is, right, connected to the container, and inside the data directory, I asked you to create a file called shankar.txt, this new container. Shankar.txt is created, then here you can see the shankar.txt file is created inside my DevOps directory. It is not a volume, it is simply a DevOps directory, correct? So ls mkdir DevOps. So now here I have created DevOps directory. Then if I try to run the command instead of touch, the DevOps and Shankar, that's it, right? So now here Docker volume ls. Right, so here what happened here is, when the moment I have taken the DevOps directory of my what's called system, it has converted into a volume in the background, right? So one is create a volume and attach it, or take any what's called any path, any directory of the machine, then use it to mount it, so that your Docker will be created a volume for you automatically. The other way, so 2 ways you can handle the volumes. One is upfront create it and use it, or else take any part of your system, then automatically your Docker will be taking care of volumes, right? So this is the volume section, guys. Creating the volume, create a volume and mount it, or use any directory, mount it, automatically the volumes are going to create in the background, right? So then very important, then expose option, we'll see, I will show you mounting volumes. This is done, right? So now I want to delete my containers and my images, because, right, so here when I'm going to start working with the Docker containers images, it's going to occupy some space. So now here unnecessarily there are containers are running in the backend. So now these containers are not required for me. Just for testing I have created it, then later on I don't want it, right? So I don't want to maintain all these containers, right? So now to remove the containers, right? I don't want the container means I want to terminate it. I want to remove it, right? So to remove the containers, docker rm is the command. One second, please. Okay, right. So now when I don't want to maintain any containers because no use for me right now. So now to remove the containers, docker rm is the command. So now here I'm going to remove this container, docker rm, then followed by the container ID. Right. So now here what it is saying here is you cannot remove the running containers. Right. So now stop the container before attempting for the removal or do a force remove. The first thing is stop the container. Now to stop the container, docker stop is the command and container ID, so that it is going to stop the container for us. Again, if you want to write, so now docker ps, see the container is gone from the list, from the active list. I cannot see the container, this container. Then because it is a non-running container, so now you can see that a container in the docker ps-a, so that in the non-running list you are going to see somewhere many containers are, this is the one 80 right, b80 likewise. So now here we have a command called start or stop, so that temporarily you can stop the container, then also you can start the container. You can stop and you can start the containers temporarily. Right. So now to start the container back, docker start and container ID. So now docker ps, the container is back. See, up 2 seconds ago. We created 1 hour ago. Just now we have started. Likewise, you can start and you can stop the containers temporarily stop and you can start the container. But we are not going to use it because we don't require to stop the containers. If you want to use the container, you're going to use it, then we are going to terminate it. But yes, we have the options, right? So now when you want to remove the containers, stop the container, then go for the remove or do the force removal. First we'll go with the stop and remove, then we'll go with the force removal, right? So now here I want to stop it. Sorry, I want to remove it. So for that, the running containers cannot be removed, so that you need to stop it first. Docker stop and container ID. Now docker rm, then container ID. Gone. Now the container is not anymore. Now you cannot start the container. Start, fail to start the container. No such container. Container is gone. Right. So likewise, you can stop and remove the containers. That is one way, or you can do the force removal. Right. So now here, I want to remove this container now. This one. Right. So docker rm, then -f, force removal. So for that, you don't require to stop. You can skip the stop command. Straight away, you can remove the containers by using force removal. Nothing but the -f is the option. Enter. Gone. Right. So now docker ps, likewise. So now here I want to write, there are, see here there are 10, around 8 to 9 containers are there, but sometimes you are going to see 50 containers, 100 containers. Now you want to remove the containers one by one, means it will take around 30 minutes to 40 minutes, right? So to remove that is the time waste process for us. I want to remove all the containers in a single shot. I don't want to go one by one like this, right? Options, guys, these are the options. Now to remove the containers in a single shot, then docker rm -f, then dollar curly braces, sorry, I mean round brackets, docker ps, right? We know ps is the command to give you, it is going to give you the running contains information. -a, running and non-running. Q for is nothing but quiet mode, so that it is going to give you all the list, right? All the list means running and non-running contains information. Docker ps -aq. These many containers are there right now. Now I want to delete all in a single shot. Now these containers I'm going to pass as input to my docker rm command, right? So docker rm command will be taken as input of these IDs. So dollar and docker ps -aq, done. See, all are gone. Single shot, all the containers are gone. So now here docker ps, no more containers. Docker ps -a, no more containers. Right, both running and non-running are gone. So likewise, docker images. Right, you can see here there are 3 images are there. Right. So now here I want to delete the image. Hello world is not required unnecessarily. Suppose Debian is not required because it is taking 114 MB. Somewhat big for me. I don't want it. Right. So now Docker to remove the images RMI. Remove I for image. Remove image. RM is for to remove the containers. RMI is for to remove the images. Right. So now here use Debian. Gone. Docker images. Right. So now here docker run -dit. I am going to create a new container here with the help of Ubuntu images. Now docker ps, there we can see one container is running for the docker images. Now I want to delete the image. Right. So now earlier case I tried to delete the Debian. By that time it won't show me any objection. Right. Simply when I run the command rma, simply delete the image for the Debian. So now here I am trying to delete the Ubuntu image. Now I'm going to try to delete the image. Now docker rmi Ubuntu. Now it's going to show me. It is not allow me to delete it. Right. So here you can see conflict. Unable to remove the repository reference because someone is using this image. Right. Just now I have created a container. This is the one. This container by using the image called Ubuntu. So that is the reason if some container is running in the background for the same image, you cannot delete it. That's what it is showing here is. Right. So now even though I want to delete it, I'm not going to care about it. What are the containers are running with the image? I don't want to bother about it. Simply I want to delete it. For that, same forceful removal. Docker rmi -f, then Ubuntu. Force remove. Gone. Docker images. Right now only hello world is there. Docker ps. Right. So here I can see the container. So now here what the command is done here is it has deleted the Ubuntu image, but it has left over the image which is going to use by the current container. So now this we are going to call as a dangling images. Dangling images are nothing. This is one of the intro question here. Sometimes people are going to ask you what is a dangling image. Okay, so the dangling is nothing but it is not going to have any name. It is not going to have any name. Like, so the best example can be, suppose I want to launch a Jenkins container, right? So now here what I'm going to do here is I'm going to run the command docker run -dit, then Jenkins is the image name I'm going to pass, so that a new container is going to create with the Jenkins image. Now we know Jenkins is a dependency on the Java, right? So now when I want to run the Jenkins, Java is mandatory for the Jenkins. So now here now when I run the docker run command, so what the docker will do, first will bring the Java image, then after that it is going to bring the Jenkins image. Now both will together launch a Jenkins for us. Java and Jenkins, both the images will be created a new container for us, so that you can work with the Jenkins. So now here when I delete after the work, whatever the things I want to do on the Jenkins, once that is completed, then I'm going to delete the Jenkins image, right? Docker RMA Jenkins image. But the Java is not going to delete because I am not mentioned to delete the Java. Like means the dependency images. The dependency images are going to left like that. Those we are going to call as a dangling images, right? Like orphans, right? So those guys will not be having any parent. We have deleted the parents, right? So now here those will be left like that. So now these images we are going to call as a dangling images, right? So now after I have removed the image, that the image which are required for the Docker container that is left like that. So now it is going to run something like that. Even though I have deleted the container, it will be left like that. So now here you're not going to have any image name. So with the image ID, you are going to delete it, or we have an option. We have an option to delete the unused objects of Docker. I will show you. Right. So now this is the concept of dangling images. Right. So now, so let me remove this container as well. So now no more containers. Docker images, still I can see the dangling image, right? So because no relation with the Docker container images, okay, anyway, one is not going to delete. So now here, Docker RMI -F, let me try to delete all the images in a single shot. Docker images, deleting all the images in a single shot. Right. So now here it is going to delete all the images, Docker images. Okay, fine. It is deleted actually. This image also gone with the command Docker RMI. Sometimes even though the dangle images are not going to delete, even if you are try to run the commands, it will be left like that only without any names and without any IDs. So those can be deleted with the option called Docker prune. One second, guys. Let me see the command. Okay, Docker system prune. Right. So Docker system prune is the command which is going to delete all the unused stuff, like all stopped containers, right, the stopped containers which are not using, all networks not used by at least one containers. Networks we'll see, now the network stuff we are going to see later. All the dangling. Just now we have discussed about the dangling images and caches. The danglings are what are the danglings are going to build the caches, those will be removed. So if I give yes, it is going to remove all the stuff. Total reclaim 0 because we have deleted all the stuff. That is the reason nothing is deleted. Usually this is the command which we are going to use when you want to delete all the dangling stuff. Dangling because it is not going to delete even though with this Docker RMA commands. With the RMA commands, the dangling images are going to delete sometimes. By the time the Docker system prints the command which we are going to use to delete all unusual stuff. Right. So now here deleting the volumes, deleting the containers, deleting the images. Right. So now Docker, let me recap it. Docker rm is the command to delete the container. Docker rm-f delete the running containers without stopping them, and Docker rm-f and $docker ps-aq is the command to delete all the running or non-running containers single shot. This is a single shot, right? So likewise Docker image rmi is the command to delete the image Docker rmi-f is the command to delete the image forcefully, and docker rmi-f $docker image is the command to delete all the images. These are the commands which we are going to use to delete the stuff. Right. So now here, now the last one is docker system prune is the command to delete unused stuff. This is the one. Right. So right guys, unusual objects. So now here I have given the image deletion command, and here you can see the containers removal. There is no volumes, docker rm-v under the volume list. Volumes also can be deleted. Right. So let me delete the volumes also. Let try to delete the volume, docker volume. Docker volume rm DevOps. So to delete the volume, docker volume rm DevOps is the command. Docker volume ls is the command. So now here the DevOps volume is deleted. You can see docker volume, my volume is left. Right. So if you want to delete all the command, all the volume, docker volume rf $, then docker volume ls is the command, so that you could delete all the volumes. Right guys. So now here, as of now, we have seen in the commands which we are going to use to work with the Docker containers, creating the containers, right? Passing the environment variables and changing the working directives, creating the volumes and attach the volumes to the containers individually. Right? When go to the real time, right? So now here we are going to launch the applications with the Docker containers. Right. So your code is going to launch to the Docker containers, to the means with the Docker containers. Now you are going to do the validations or whatever you want to do it. Right. So now here, how the applications are going to work or are going to launch with our Docker container. Right. We'll see an example here today. Then we'll see the other stuff in our next classes. Okay. Right. So now here, a application setup, nothing but WordPress is an example application which I'm going to take it as an example to see how it's going to work with the Docker container. Okay. Right. So now here, if you guys know or don't, I don't know, WordPress is a blog. There, a blogging application. There you can create our own blogs. Right, you can have your content. You can place your content like videos, images. You can create our own blogs, WordPress. Right. So now the WordPress application is a combination of, we are going to call it a LAMP stack. WordPress application is going to call as a LAMP stack. LAMP stack. So LAMP stack is nothing but L for Linux, LAMP, LAMP. L for Linux, A for Apache, M for MySQL, P for PHP. This WordPress application is built with Linux, PHP, MySQL, and Apache. It's the stack of WordPress. Right. So now when you want to set up this WordPress on your machine, this WordPress on your machine, so then some installation process will be there. So that suppose one person install on CentOS 7. Right. So now here we need to follow this steps to set up the WordPress on your machine, on your desktop or laptop, whatever it may be. Right. Suppose if you want to set up on CentOS 7, and these are the instructions which you need to follow to set up this WordPress site application. So these are the steps. Right. So finally, you're going to see this is the application, something like that. Right. So now this is the what. Right. So now here I want to launch it with the help of Docker. Right? What is the advantage of Docker? On fly. Everything can be done on fly. I don't require to have a new mission, AWS instance, then install all the stuff. I don't want to do all the stuff. I need a WordPress, just I want to practice it, or I want to see something on that. Right. So for that, I'm not going to create a separate AWS instance or a virtual machine, then go and install the WordPress site and use it. Simply, I will go and I will do it with my Docker containers. With the help of Docker, I can do it with the on-fly. Right. So now here, how you are going to do? Right. Only the point which you need to focus here is images. If the image is available in the Docker Hub and the community, you can launch it. If the image is not available, then only the problem will come. If the image is not available, then we can create it cannot create the containers. Now we need to build up our own images, then create the containers. Right? But 90% of the images are available for our requirement. Only the 10% are not going to be available. For that, we are going to create our own images. We'll see. Now the process will be for a Docker container, it requires the Docker image. The Docker image will be built with the Docker files. That's for the process, right? So now here we are not covering as of now the Docker file stuff. We'll see the Docker files later in our next class. As of now, we are focusing on the containers and images. So now here I want to launch the WordPress site. I don't want to have a separate mission. I don't want to install the WordPress. On fly, I want to launch it. So now to launch the on fly image, you require a image. The WordPress image is required. If I get the image, simply I can create a container. That's it with the image. Right. So now for that, what we need to do here is simply you need to go to the Docker Hub and search for any image is available with the name called WordPress. If it is available, then our job is done. Right. So now here I will go to the Docker Hub. Then here I am going to search for WordPress. Yes, it is available. That's it. Means our job is done. Right. So now here, as I said, the WordPress is a LAMP stack. Right. The LAMP stack is nothing but is a combination of Linux, Apache, MySQL, and PHP. Right. When I say MySQL means it's a database. Whatever the content we are pushing into the application, the content will be stored in our database. That every application requires the database. Right. Likewise, our WordPress application also requires the database. The database which they have used is MySQL. So while you are going to configure the WordPress on your server, on your mission, then first thing will be you need to set up the database. So, right. So you can see here MySQL is created the root user. Right. So now here, once the MySQL is ready, then they are going to create the database called WordPress. Right. The WordPress database is created, and to maintain the database, user is going to create here. Now for the user, they are providing all the privileges. Right. So to maintain the database. So then finally they came out from the database. Then WordPress, the front end is going to install. Then once the front end is installed, now the configurations, application configuration. Then here you can see your database connectivity step, connecting to the front end to the back end, the database connectivity to the front end and back end, so that your application front end is going to connect to the back end. Then it's going to maintain our WordPress application. This is what right. We have the front end, we have a back end, and the front end and back end is going to communicate one each other. Nothing but the configuration is establishing. Then our application is going to work smoothly. So now here the same setup you need to do. So now the advantage of the containers are you don't require to do any kind of this installations, this configurations. Automatically you are going to get the default stuff, predefined stuff. Right? Predefined stuff means images are available. Just take the images and utilize it properly. Right? Properly means you have now the application is a two tier application. One is a front end and one is a back end. Now we are going to take the two images, nothing but one for the front end and one for the back end. Means one is your application, my WordPress site, and the second one is MySQL database. Right. So now here, once you got the two images, means two containers, then you are going to link your front end to back end, so that the communication will be established between the front end and back end. Then your application will run smoothly. That's what we use. Right? That's what using properly. Right. So now here, let's see how we are going to connect the back end and front end, and how we are going to launch the WordPress finally. Right. So let me go to our slide again. Right. So now the WordPress site is a two-tier application, nothing but two parts. One is the front end and one is the back end. Now I'm going to create the SQL container, nothing but MySQL container I'm going to create, nothing but the database. Right. So now here Docker run -name. This option is nothing but we have not covered this option in our Docker run command. Right. So now here, as I said, every container is mapped with the container ID for the identification. Container ID will be mapped. As of now, we have used container IDs only, a kind of unique numbers. Right. So now remembering this container IDs are very difficult for us. So that is the reason we are going to give the names like our server name, host names. Instead of IPs, we are going to refer the host names. So likewise, now the containers also will be having the container name so that you can refer with the names instead of using the container IDs. Right. So now if you want to allocate a name to the Docker containers, the option will be -name. -name is the option so that a name will be allocated to the Docker containers while creating the container. So now here I am going to create a new container with the name called WordPress SQL. This is the name I'm going to allocate to my container. Right. So now here you know -e means environment variables, right? -er, -env, -env, -file, right? We have seen that one. So now here to connect to the database, what I'm going to do here is I'm going to pass a password, MySQL root password, some password I'm going to use so that if I want to connect to the database of MySQL, I can utilize this password to connect to the database, right? So now -d, right? D means we know daemon mode, run in the background. Then MySQL is nothing but your image, right? So Docker image, right? I want to have a Docker container with the MySQL, right? With the MySQL you want means you require the MySQL image. So now this is the version 5.5. MySQL 5.5 is the version which I am going to use. So now here I am going to create a container, nothing but the backend, the database. Right now I'm going to create. Right. By default, MySQL is not available. Right. That is the reason the MySQL database is going to launch. Done. Right. So now Docker images. Right now you can see MySQL image is downloaded. Tag is 5.6. The size you can observe hardly 200 MB, very less. Right. So Docker PS, a database with 200 MB means it's a great thing, right? So now here you can see a container is running with the ID. Now you can see a name is allocated with the called WordPress SQL. Now going forward, I can use this name instead of the ID to refer my container, this particular container, right? So now this is our image, MySQL 5.5. The image is done. So now database is ready, correct? So now here backend is ready. Now I need a front end. Now the front end is my WordPress SQL image, sorry, WordPress image, the front end, right? So now here I'm going to launch, I'm going to deploy, or I'm going to create a new container for this WordPress. Right. So now the word container Docker run -name, right? So now this container name I'm going to allocate as a my WordPress site, my WP. And here you can observe here WordPress SQL is the name I have given to my what is called my database container, WordPress SQL. Right. So now it is going to connect to what MySQL image. Right. So this is nothing but MySQL image. This is the what. So now here what I'm trying to do here is WordPress SQL is nothing but my new container. It is pointed to MySQL image. So now this database has to be connected to my front end, nothing but my WordPress site. It has to be connected. This backend has to be connected to the front end. For that to connect do these two containers, we are going to use an option called -link. In the Docker world, -link is an option so that you can connect multiple containers. You can connect one container to another container with the help of -link. So now here I'm going to tell my Docker that whatever the container I'm going to create, it has to be connected to the container called WordPress SQL. So like so using properly the sentence, that's what here, right? So now here I know there are images are available to launch the MySQL database and also to launch the WordPress. But when I want to launch the WordPress application, simply taking any one of is not sufficient. If I use the front end, if there is no back end, you cannot launch the application. You cannot access the application. If I use the back end, if the back end is not having the front end, then you cannot access the application. You require the both has to be configured one each other, both has to be communicated one each other, then only your application will be up and running, right? So how we are going to communicate one each other, right? So the two, now here there are two containers are running. Earlier here only one server. In our old days, in our right, the previous generation is only one server we are going to take. On the server we are going to set up everything like this, so that the proper configuration is going to take care of the launching of application. But here in our current generation, right, in the current technology, now we are going to divide into pieces. So now each piece will be deployed into separate servers, separate containers. Now we are going to talk one to each other. We are going to communicate one to each other, right? So now the communication will be established between the containers with the help of -link option, right? So now you know -p is nothing but publish or expose the port number. Publish or expose the port number. So now here, if I don't mention any port number, right? So now what I explain in our classes here is, if you want to access the application, we require to expose the port number. That's what I explained to you guys, right? So here, if you guys observe here, right, the container port is going to expose in the outer world with the port 80, likewise -p. So this is overwriting of the port numbers, right? Overwriting means the default will be overwritten with the new port number. So if I don't use any ports, explicit port numbers to override, so if I use something like -p, then the default port, whatever is there for the WordPress site, it will be exposed to the outer world. The same port number will be exposed. If any conflicts, then we are going to override with our new port number. If there are no conflicts, then it simply can use -p, so that the default port can be used into the outer world also. But to use it outer world, you have to use -p, so that the Docker will understand, okay, this port has to be exposed, otherwise you cannot access it. If you are not using the -p, you are not going to access the applications which are running in the Docker into the outer world. Definitely you have to use the option -p, so that the Docker will understand, okay, this port has to be exposed. If you want to take the default port or you want to overwrite it, that is in our hand. If I use -p, it will take the default one. If I use -p, then followed by some port number, means the default will be overwrite. We'll see that one also. So this is one way, nothing but the default can be used into the outer world. And this is my image name, WordPress. Right. So now here, let me go and see Docker PS, so that there should be two containers running in the background. Sudo -a Docker PS. Right. Now you can see there is a container called with the name WordPress and a container name called with WordPress SQL, front end and back end. Right. So now here we can observe here the port is exposed, right? So 32768 with any IP. 00 means any IP, means by default, like any IP means any, with any IP you can access the application. With any IP means wherever the Docker is running, the machine IP I can use, but the Docker don't know which machine is connected and what is the IP of the machine. The Docker won't understand. That is the reason it is given as 00, so that any IP can be taken. Right. So 3306 is the MySQL port number. We have not given any -p option for the MySQL. So now you cannot access the DB into the outer world. You should not access, right? DBs are sensitive. It should not be given access to the outer world. Right. So now here, let me go and provide access to the server server means my instance, AWS instance, because I want to access the application, right? So to access the application, the port is using 32768. So by default, our AWS instance is going to allow only the 22 port number. So I'm going to give access to the other ports as well out of it. First time. That as I said, you cannot use the Docker container IPs to access the application into the outer world. The IPs are only for the internal purpose. You have to use the container application port number, and we have to use the Docker run host mission wherever the Docker is installed, the host mission IP address. Right. So now here my Docker is running on this instance. So now I'm going to take this instance IP. Then I'm going to use 32768. Now you can see WordPress is launching here. Okay. Now you can see WordPress is launching. Right, so WordPress site is ready. English, United States, site title, username, Shankar, password, the connectivity to the applications. Okay. Confirm user quick transfer. Install. Login. That's it. My dashboard is ready. Here we can post your reports. You can see the media. So it's an application, a kind of application, blogging application, nothing but the WordPress. Right? Whatever the application, we are not going to bother about it. But how easily you are launching it? We have launched it, right? With the help of Docker. You don't require to go take the servers, install it, blah blah. Simple, right? By using the images. So that's what the advantage of the Docker, right? You can play with the Docker, like you can use the Docker like anything, right? So we'll see more examples, this stuff. Then slowly we'll go to the advanced area of the Docker. Okay. Right, guys. So today I'm going to stop it here. Let me know any doubts, or we are good.
Fine, Shankar.
Yeah. Thanks, Priya. Okay then. Okay, guys. Then so please practice it. Docker is very important for us. Okay. So if any doubts, post on the WhatsApp group. Okay. So to the end of the day, I'm going to share this recording. Yes, once it is ready. Okay. Then that's it. See you next weekend.
Thank you, Shankar.
Thank you.
Thank you, Shankar.
Bye-bye. Thank you. Bye-bye.
Thanks, Shankar. Bye.